Welcome to Switzerland.
The countryside must be nice.
Hello, good afternoon on this beautiful, well, it depends where you are. I do not know what the weather. Here it's beautiful because I'm inside, I have a lot of light. It's day 4 of the WeAreDevelopers Live Week number 2, and today is Blockchain Day. So let's get ready. This program is brought to you in partnership with Digital Switzerland and is powered by Helvetia, and today's partner is Blockchain SV, and Steve Shadders from Enchain will be your moderator today. So before we go into this, I got a list of stuff, you know, professionally, old style, from my colleagues who wanted you to know some of the things coming your way. There will be a survey at the end of the week coming into your email inbox, and it's possible to win some Amazon gift cards or goodie bags from Zurich Tourism. This will be definitely worth that. And also do not forget, today there is a happy hour at 7 p.m. It's bring your own drinks. Can be with or without alcohol, whatever you like. But please, you need to register for that. And tomorrow, if you want to participate in the workshop DevOps 101, together with JFrog, which is powered by the Women in DevOps, please register. There are some places left, so I hope you are lucky, and I think it will be a great thing. That's the one tomorrow at 10 a.m. So do not forget to register. But the most important part of my talking today is that I say that we are subject to the Berlin Code of Conduct. And Berlin Code of Conduct in the short version means please behave. And in the long version, you can see in this beautiful animation we created for you. So here I am again, but only for a short second. Just hopped behind the scenes, and you will not believe Steve is already there. and waiting to rock the dance floor. No, of course, the stage. So I will roll now your intro and then hand you over to Steve, and enjoy the day. Do not forget to ask a lot of questions in Slido on wearedevelopers.com/live-week. And yeah, see you later.
Hello, everyone, and it's a pleasure to be here. I will be your host today for Blockchain Day. And we've got an interesting array of speakers covering a number of different blockchains, and there's a focus on the developer side as well as the enterprise side, which of course is of interest to developers because that's what generates the jobs and the entrepreneurial opportunities. So I'm going to begin today talking about Bitcoin SV, which is a blockchain that you might have heard of. We're not without our controversy, but there's a lot going on in the Bitcoin SV ecosystem. So if we just take a moment whilst I start up the presentation. And let me switch screens so I'm not looking away from you. No, sorry, quick technical difficulty. And there we go. So Bitcoin SV, massively scaled blockchain to meet developer needs. And those two words, massively scaled, are one of the differentiators, I think, between Bitcoin SV and a lot of other blockchains. I'm going to challenge some of the ideas that are commonly held about blockchain in terms of its scaling capacity. And I hope that that I can convince you that that Bitcoin actually can scale in the way that that was originally described by Satoshi Nakamoto right back in the very beginning. But first, I'd like to take a moment to talk about what is Bitcoin itself, and I'm going to begin with a quote. True history is altered by those who read it to benefit their own aims and to self-affirm their own conceptions. This is a quote by a Japanese philosopher by the name of Tominaga Nakamoto, who lived in the 18th century. And that name might be somewhat familiar to you. There are a few people who theorized that the work of Tominaga Nakamoto was actually in part the inspiration for the Bitcoin white paper. Tominaga was a philosopher, and he was primarily concerned with the accuracy of historical record. In his case, he particularly focused on the canonical texts of various religions, one of them being Buddhism and I believe Confucianism. But he makes this statement here about the alterability of true history, and this is primarily the problem that he tried to solve in his life work. And I believe there's a strong argument to be made that this is a problem that Bitcoin actually solves, because it embraces the concept of public distribution of a record of events in order that any alteration of that record is detectable by anyone across the world. And this has applications that go well beyond preservation of historical texts. It has applications in business. It has significant implications for society as a whole. And so I want to begin with the concept of notarization. If you think about what Bitcoin is, often people think in terms of its payment processing capabilities, its ability to transfer value from one person to another. But when you think about the act of transferring value as it occurs in the world, even before Bitcoin, there's always a lot of records associated with that. And that record keeping was part of what allowed economy to grow and trade to flourish across broader and broader geographical regions. It began thousands of years ago with the Sumerians who came up with the earliest forms of accounting, which is often described as single entry accounting, and that enabled trade in smaller regions. It extended sometime later, I won't try and put a date on it because my history is not that great, into a thing called double entry accounting. And roughly speaking, it's somewhere in the medieval era, possibly a little bit later. That's what enabled global trade to proliferate, because records had some mechanism of authentication. They couldn't be altered easily. And when records were recording things that might be happening on the other side of the world, of course, that's important. Bitcoin kind of takes that concept a step further. And it's this notarization aspect that is well recognized in the pre-Bitcoin days that Bitcoin allows us to kind of extend. So I'm fond of saying that Bitcoin is, in a more general way of describing Bitcoin, is that it's a global and immutable record of events. Now, payment is just a specific type of event. It's a specific form of the general use case of Bitcoin. And of course, this notarization is something that we've always been able to do. It's happened in the offline world for hundreds of years. We've had these agents that we call public notaries. I'm sure they've had many different names over the last few hundred years. But their job is essentially to act as a trusted authority, to take a document, a record of something, and attest to the truth of that document. And it gets used later on, perhaps in resolution of a dispute, or in normal course of operations. It's simply used to give confidence to the recipient of a document that it is actually genuine. Of course, eventually that function moved online, and we have a number of online notary type services. The people that sign the SSL certificates that power the internet allow us to use secure connections to websites. They're a form of notary. We have things like DocuSign that allow people to sign things online, and it's always important for that signature to be connected to some real world identity in order for it to carry any weight. But we can do better than that. And Bitcoin was the first of the technologies that ever tried to address this issue. Bitcoin has two key features, I suppose, that differentiate it from some of its competitors. One is that it's public, and it's the publicness of a blockchain when it's acting as a notary service for an event, be it a payment or anything else, that effectively makes it unalterable, untamperable. And also there is, of course, the issue of capacity. A service like this is no use to a global economy if it can't actually scale to service that global economy. So why does this capacity matter, and why does the publicity element of it matter? Well, public makes honesty and transparency pretty much a key factor. Once a record is public, it's obvious to anyone if it's ever changed. And we've seen instances in the past where signing authorities, let's call them digital notaries. An example would be one called DigiNotar, and you can see in the name what that's supposed to mean. Had their root keys hacked, but because there was no public record of everything that they had signed in the past, going back 5-10 years, there was no way to authenticate anything that had been signed previous to that hack. Now that's actually not true when you notarize something in Bitcoin. Even if Bitcoin itself was completely compromised, or a signing authority that was making use of Bitcoin was compromised, the historical records still actually have meaning. They can still be trusted because they've been known publicly by a wide array of people who have no interest in hiding a forged record in collusion with each other. Enterprises certainly want this capability. And there's a lot of people that actually want transparency, because when transparency is the default and there are rewards for honest behavior, it makes it easier for people to actually be better to each other when honesty is the simplest path and the path of least resistance. A better and more honest world where people and enterprises can build free from harassment. And it's the publicity that allows us to use a miner's base instincts to make honest security of the network the most sensible choice. And it's simply because any miner that detects a dishonest behavior on behalf of another miner is rewarded for disclosing that. And so we get down to the magic 51% number that's often used with respect to Bitcoin security. It requires a majority of the Bitcoin miners in terms of their hash rate to collude together to be dishonest in order to break the security guarantees of Bitcoin. So I've listed here a few of the common or the more well-known blockchain solutions in terms of their ability to address privacy as well as capacity. Some of these points might be up for debate, and I'm more than happy to have those debates, but this is our assessment, I suppose, that we have made in Bitcoin. And just as a very quick example, we'll get to more of these later, of the use cases for Bitcoin. In fact, we'll hear from one of the people behind Chronoverse a little bit later. It's an esports monetization platform that uses technology for a decentralized and transparent multiverse of competitive gaming. Chronoverse is a fascinating blend of the gaming world and the blockchain world. And Chronoverse actually made a decision to move on to Bitcoin SV for a few simple reasons. Primarily because it's faster and cheaper to conduct trades. As I say, we'll come back to this in a little while, so I won't go into it in a lot of detail. But the fact that Bitcoin SV is capable of handling millions and millions of transactions without slowing down is one of the primary reasons that we hear from applications that want to migrate over to Bitcoin SV. So Bitcoin SV, or Bitcoin, is essentially the fusion of data and money. I'm fond of saying that a Bitcoin transaction is actually a smart data packet. It's a chunk of data which is wrapped up in other functionality like authority, transfer authorization, identity, if you want it, and numerous other things. But down to trying to explain a little bit about what Bitcoin SV actually is. We argue that it's the only version of Bitcoin which actually adheres to the Bitcoin protocol design and vision of the creator, Satoshi Nakamoto, a peer-to-peer electronic cash system and a global enterprise blockchain. Satoshi spoke about both of these things, and the protocol itself is a critical pillar of the Bitcoin SV project. There are 4 pillars upon which Bitcoin SV is built, and as I say, a stable protocol. There's some controversy around this, which I think is rooted in misunderstanding, because since Bitcoin SV acquired the name Bitcoin SV, we've actually had 2 hard forks, one of which was a significant protocol change, the Genesis update, which I'll get to in a minute. But all of those are actually intended to bring the Bitcoin protocol back to the original design that was put forward by Satoshi Nakamoto. And it is absolutely our intention, once that work is complete, which will take 1 more hard fork, which is what we, that is the roadmap and the path by which we intend to get there. Then the Bitcoin protocol itself is intended to be locked down forever, which was stated and articulated very clearly by Satoshi. The protocol was set in stone from day one. Scaling, of course, is a significant factor of Bitcoin SV. It was part of the reason why the name Bitcoin SV even came to be. We believe that the model that Satoshi proposed for scaling Bitcoin works, and we've got good reason to believe that it does work. In fact, we have proven that it does work, and we'll get to that in a bit. Security of the blockchain, this refers to the stability of the code, the safety of the code. When you've got code that is underpinning potentially a global economy, that code has got to be robust. If you want banks to use it, there's a whole lot of QA and other layers of assurance that are required. And that is exactly what we intend. We want global financial institutions, we want governments, we want big businesses, we want small businesses. We would like everybody to be able to use Bitcoin as a global plumbing rail, a global payment rail, and a global data rail. And of course, safe instant transactions, which is commonly referred to as zero-conf or zero confirmation transactions, is another one of our key pillars. Because we think that if you're in a shop and you want to buy something, you shouldn't have to be waiting 10 minutes for confirmations. The mechanisms for safe instant transactions were built into Bitcoin from day one. And I will explain a little more about that as we go on. So stability and security of the protocol is critical. Stability because big businesses won't build on something that is constantly subject to change. Security, of course, is key. People need to be able to trust the software. This is a picture of just some of the Bitcoin SV team. These are the people that work directly on the node software. In fact, this is a picture that's about a year old now. There's only about half of the current members of the team shown here. At last count, I believe it was somewhere in the range of 50 or 60 full-time engineers who are working on the Bitcoin SV software, as well as associated pieces of infrastructure. We take that security very seriously. We've had the software independently security audited more than once. We've used a company called Trail of Bits, which is probably familiar to a number of people in the Bitcoin SV system. And they've assessed not only the Bitcoin SV software that goes right back, it has its legacy in Bitcoin Core. It is essentially forked from the same code base. So not just the changes that we have made since the Bitcoin SV team was formed, but the actual base software itself, which has its legacy right back to the original code written by Satoshi Nakamoto. So a little bit of quick history about Bitcoin SV. Where did it come from? What is it? BTC is the Bitcoin that most people are probably familiar with when you use the word Bitcoin. It began in 2009 with the first block that was the Genesis block that was created by Satoshi Nakamoto, and then the first block line, block one, 9 days later, due to some stuff, I suppose, that happened in the interim. And there was a long debate about the Bitcoin block size that culminated in Bitcoin having a hard fork in 2017. And that led to the ticker changing to BCH and the name, which many of you will know, Bitcoin Cash. Bitcoin Cash then continued for another 18 months. But what was very apparent to us was that the idea of bringing the protocol back to the original Satoshi design was not an idea that was shared by everybody in Bitcoin Cash. There were scheduled hard forks every 6 months to make changes to the protocol, and there was no end of argument and disagreement about what those changes should be. There were people that wanted to improve the protocol, or at least believed that they were improving the protocol, and there were people that wanted to bring it back to the original. And that culminated in what's commonly known as the hash war of November 2018, where BCH and BSV went their separate ways. In that particular hard fork, Bitcoin SV restored some of the disabled opcodes in Bitcoin script, and we raised the block size limit again from 32 megabytes up to 128 megabytes. We've subsequently raised it a number of times, but it is interesting to note that since 2018, and since the fact that the proposition of Bitcoin SV was protocol stability, and that there would be no arguments about protocol changes, improvements, etc., other than restoring the well-documented original design, there has been no argument at all in the Bitcoin SV community about protocol changes. There's been no shying away from the hard forks necessary to do the work to bring the protocol back to original design, but it's allowed an unprecedented period of developers simply focusing on building on top of Bitcoin rather than trying to tinker with Bitcoin itself. And a lot of this work culminated on the 4th of February this year with the Genesis hard fork, or we like to call it the Genesis upgrade, which went a long way. We think about 95% of the way toward restoring the Bitcoin protocol to its original design. And that includes some things that were the root of some of the block size wars that happened in BTC between 2014, 2015 perhaps, and then 2017, which culminated in Bitcoin Cash. So we removed many of the artificial limits, not just the block size, but transaction sizes, data capacity, limitations on script. We restored the full functionality of the Bitcoin scripting language. And that goes not to just restoring some of the opcodes that have been disabled, but also removing limits on those scripts, such that many things that were theoretically possible on BCH and BTC are actually now possible on Bitcoin SV. And that means unlocking the real potential of Bitcoin. Satoshi put a scripting language in Bitcoin for a reason, and developers that are working on top of Bitcoin for the last 8 or 9 months have finally been able to start exploring that potential. And of course, we removed a couple of the changes that were made to Bitcoin SV, which I'm sure that people at the time felt that they were improvements, but we felt that to keep in line with our proposition of restoring Bitcoin, that it was important to take some of these out, because some of them did in fact have unintended consequences. And this is a quote that I mentioned earlier from Satoshi Nakamoto. The nature of Bitcoin is such that once version 0.1 was released, the core design was set in stone for the rest of its lifetime. This is important because Bitcoin is a protocol. It's a very low-level protocol. It's plumbing that most people probably shouldn't see in their day-to-day interactions with it. I would liken it to protocols like TCP/IP and HTTP. These protocols have changed mildly over their lifetimes, but they're largely intact and largely what they were at the beginning. And it's not to say that the protocols themselves were perfect, but people designed around those limitations. And without the basic HTTP that we have today, an entire global industry of the internet never would have been born. I can imagine some of the disruption that would have happened had those protocols been changing constantly. And to give an example, I suppose the transition from IPv4 to IPv6, it's been around. IPv6 has been around almost as long as I can remember, and that transition is slowly happening, incredibly slowly. But in the meantime, the limitations of IPv4 aren't really stopping anybody from getting anything done. And so let's talk about scaling. I'm going to start with an example that Satoshi himself gave, which was Visa, when he talked about how Bitcoin never really hit a scale ceiling. Bitcoin BTC with a 1 meg block limit, which was a limit that was originally put in place by Satoshi. He was convinced by Hal Finney that it was needed early on as a spam mitigation measure. And this was largely because of the fact that at the time Bitcoin had no value, and so there was no disincentive for people to create millions and millions of transactions because the transaction fees were essentially zero. This is not true anymore. If you try to go and create millions of transactions on BTC, Bitcoin Cash, BSV, Ethereum, or any blockchain, you're going to run out of money pretty quickly. But he did clearly give the example of the Visa network, which processes on average about 2,000 transactions a second. We've already got there with Bitcoin SV. We've proven that we can beat and exceed Visa, and we've only really just begun that work. And it's not just us that says that there are scalability problems. Vitalik himself has talked about the Ethereum blockchain being almost full. In a recent article, he talked about how some of that scaling work is going to take years. And I think in part that's because of some of the unique design challenges around Ethereum. But having gone through the Bitcoin protocol in detail, step by step, as we conducted the early feasibility studies of a project called Terranode, I've certainly become convinced that Bitcoin was actually designed to scale from day one. And here it is again. I keep jumping ahead of myself and quoting Satoshi, not realizing there's a slide coming up. Bitcoin can already scale much larger than Visa with existing hardware and for a fraction of the cost. It never really hits the scale ceiling. If you're familiar with this quote, you'll know that it goes on to actually give a much more detailed description of how it can work. But Bitcoin was designed, I've made the claim that Bitcoin was designed from the very beginning to scale. And there are a plethora of reasons that I can give for that, which would turn into quite a long technical conversation. But I'll just give you a couple of examples. The Bitcoin scripting language contains operations called push data, which is how you actually get data into a Bitcoin transaction. And there are 3 versions of this, and one of them is called op push data 4. And it is designed because the one that comes before it, op push data 2, allows you to push a maximum of 65 kilobytes of data into a Bitcoin script. That's already larger than most people think is normal for a Bitcoin transaction. But op push data 4 allows you to go beyond the 64 kilobytes and right up to 4 gigabytes. And in fact, there's nothing stopping you from using op push data 4 more than once. The simple fact that this opcode exists makes it clear that Satoshi's intent was that, that large data could be used in Bitcoin. And of course, there is the fact that Bitcoin can scale. We regularly see on Bitcoin SV blocks that are far in excess of the sizes that are typical of other blockchains. Earlier this year, in rapid succession, we saw 2 blocks, one 309 meg, one 369 megabytes. On our scaling testnet, we've gone far, far larger than that. But these are blocks that were on the main production network that propagated in reasonable time. I don't believe these particular ones actually caused any orphans, but in Bitcoin SV, we actually are not afraid of orphan blocks. We embrace them as part of the economic model that incentivizes miners to get their act together and be able to handle scale. And of course, I mentioned the scaling testnet. The scaling testnet is a special kind of testnet that is globally distributed, where we constantly test the capacity of not just the Bitcoin SV software itself, but any applications that want to test their own capacity. And one of our milestones, I think, was a day where we managed to mine 2 gigabyte blocks, not just a single one. We managed to mine 20 of those in a row, containing between 2.7 and 6 million transactions. Which gives us a theoretical throughput of about 6,400 transactions per second. This is only 2 years after we started at a theoretical rate of about 22 transactions per second. So you can see the progress, and I don't think I've got the slide here, but I could plot it on a chart for you, and you would see that it is actually exponential progress that we're making in terms of that scalability. So I have every reason to believe that we can continue that trend and go well beyond it. And this brings us to the Terranode project. The Terranode project is a rewrite, I suppose, of the Bitcoin SV client software, the Bitcoin SV node software. We'll reuse a lot of the code that came from original Satoshi code, but it's designed to be horizontally scalable. The problem with the original Satoshi code is that it was a way of bootstrapping the Bitcoin network. It combined a whole lot of functionality for both users of the Bitcoin network as well as the miners of the Bitcoin network. And it does a bunch of things that the miners probably don't need. And it does a bunch of things that the users probably don't need. But it's also monolithic in its architecture. There's only so far you can push it. Because you can't share the load across multiple machines. You can make one machine bigger, but there's only so far that you can go with that. Terranode is designed to break up the functionality of Bitcoin SV and allow it to process and ingest masses and masses of transaction data across a cluster of machines, which means that when you need more capacity, you just have to add more machines. And this is what I was talking about earlier when I said that we had gone through every element of the Bitcoin protocol design step by step as a part of this Terranode project to work out, can we actually parallelize all of this? Is there anything inherent or fundamental to the design that prevents that? And the answer to that question is no, it's not. Bitcoin SV is an opinion that was held, an opinion that is held by every single person that was involved in that workshop. It was about 12 of us, most of them very, very senior architects and many people with years of experience with Bitcoin SV. The unanimous conclusion was that Bitcoin had been designed the way that it had been designed in order to facilitate this parallel processing capability such that it could scale. So let's move on to one of the key features of Bitcoin, which is microtransactions. And this is a consequence of allowing Bitcoin to scale. It's a common thing for many other blockchains that they have scaling limits, they have limits on block sizes. And what happens when blocks start to fill up is you start to create a fee market. And some people think this is a good thing. But we don't think that is a good thing for global adoption because it becomes a supply and demand problem. There's only so much supply. They can only handle so many transactions per second or per minute or per 10 minutes. But more people want to have their transactions processed than the available supply. And so, of course, they start bidding against each other. And that pushes transaction fees up. And we've seen some extreme cases of it. In Ethereum, we've seen $30 fees. I've seen fees of hundreds of dollars on BTC. It doesn't always happen, but it happens in moments of peak demand. And moments of peak demand, especially if you're talking about payment processing networks, Black Friday sales, for example, are exactly when you need a Bitcoin network to be able to perform. But Bitcoin SV is different because of the fact that we have no cap on the supply of this transaction processing capability. If there are more transactions, the blocks simply get bigger. And that might cause issues for the miners. They might have problems propagating their blocks fast enough and end up in block races. But from the user's point of view, none of this matters. Because if your transaction gets confirmed in one block and that block gets orphaned, well, there's a good chance it's going to end up getting confirmed in the other block as well. If a double spend happens, it's fundamentally no different to a double spend happening in a small block environment. But there are other mechanisms to handle, detect, and propagate the existence of double spend in Bitcoin SV. And the end result of this is that there is a fee market in Bitcoin, but it's not users competing for the highest price to push the price. It's not users competing, which results in the price being pushed upwards and upwards. It's actually miners competing to push the price lower and lower by getting their own costs lower, by getting their capacity lower, which enables more and more volume. And right now, the cost of Bitcoin and transactions, if you're used to the cost of transactions on many blockchains, this might come as a surprise to you, but it's less than 1/100th of a US cent. It varies a bit between 1/100th and 1/10th, but it's almost always below 1/10th. And Bitcoin SV miners are starting to implement really interesting capabilities like floating fees that enable them to keep those fees stable in US dollar terms, so that businesses who actually need some certainty about the price of getting transactions processed, they have that certainty. They don't have to worry if they're sending out 1 million transactions a day that suddenly the price of doing that is going to double because the Bitcoin SV price doubled. And conversely, when it drops, the miners don't need to worry so much about suddenly having a massive drop in revenue. So as I say, this average fee tends to float around, but the simple economics of the fact that there is no cap on supply means that there is no economic reason why these transaction fee prices are ever going to reach some of the astronomical levels that we commonly see in the blockchain world. So this allows us to do a whole bunch of things, things like reinventing the internet with a new world of micropayments. And here are a couple of the things that suddenly become feasible. Tiny payments, a few cents, even fractions of a cent. So if you could pay to post on social media and create content, that gives the readers some level of assurance that you're not just spamming and producing rubbish, but that also allows the readers to pay you for your content. Pay to store your identity and data on chain, pay to store it on chain so that you can own it, pay to read articles. We've seen this business model working really well on various platforms with low fee blockchains. And it turns out people are actually happy to pay for content. Pay to watch by the minute for video content, and of course in-game and virtual items. We're all used to, well, some of us are used to watching an ad to get some little goodie or widget in a mobile game, or paying to get in-game tokens. But usually with those tokens, you've got to pay, a minimum of $1 or a couple of dollars. Imagine being able to pay for those in fractions of a cent. And of course, it creates many opportunities for the end users of Bitcoin to get paid themselves. Imagine if you were getting paid to watch an ad rather than Facebook getting paid. Imagine getting paid to selectively give access to your information. It could be any information. It could be info about your spending habits. It could be anonymized medical information. If you want to make that available to somebody who wants to mine that information, you can, but it becomes your choice. Get paid to give your location, even get paid to read emails. There's a lot of people out there who want your attention. And right now, Google and Facebook are monetizing that fact because they believe that your attention is worth something, but they don't want you to know that. But when you're able to transact in micropayments, it all becomes suddenly very feasible. So Bitcoin is about a world that is online and on chain. And we like to talk about a thing called MetaNet, which is a new, more commercial internet for users. The MetaNet paradigm is about the blockchain acting as a universal server. And that doesn't mean all data necessarily gets stored on the blockchain, but it can. Data for websites, content, they can be hosted on chain, their hashes can be hosted on chain, and the data can be accessed from elsewhere. But it provides a single source of truth and a mechanism to structure data that can be universal. And here are a few of the applications that we've seen people using MetaNet data structures, which leverage the concept of a Bitcoin transaction being a smart data packet to add structure that meshes with some of the guarantees and ordering guarantees that Bitcoin as a platform gives you, but also builds additional layers on top. So for any of the developers in the audience, I'd like to give you a bit of an idea of what you can build on Bitcoin SV as a developer or even as an enterprise. Here's an example who's a winner of one of our recent hackathons, a project called Coda. I know the name is a bit of a mouthful, but it's pronounced Coda. It allows you as a developer to monetize your API, which means you can choose to get paid for every single call to an API in tiny increments. And in fact, we even have a thing now called nano payments, which is a mechanism to allow you to receive payments that are actually even lower than a transaction fee, and by piggybacking off another transaction. And Coda is a perfect candidate for the use of these nano payments because they can batch a whole bunch of them together. But when I first saw the presentation on Coda, they gave an example of an open source tool. I can't recall the name of it, but it was a Node.js library that was available via NPM. And the example was something along the lines of if that person had received 0.1 cent for every download, they would have made in the region of 800,000, or it might have been $8 million. I know I've got a off by 1 order of magnitude error there, but that was roughly the number. Buscon is a Korean project that brings the capability for musicians to monetize their content on chain, either by putting the content itself on chain or leveraging the chain to allow people to literally pay per second of view. And just to give you an idea of some of the activity that's going on in Bitcoin SV, this is a bit of an ecosystem chart. These are a bunch of projects that have been built on SV over the last 2 years since we took the name Bitcoin SV. This is just the first of a few pages. Some of them have succeeded, some of them probably aren't here anymore, but it gives you an idea of the sheer rate that new projects are coming in. So these are some resources. And these are protocol layers. These are platforms that you can actually build on top of. And there's more and more of them appearing every day. Handcash Connect is an API, a payments API that basically makes the whole payments thing easy for you. It does, it allows for instant payments. It has mechanisms for end-to-end encryption. It handles blockchain data, makes it easy for you to get blockchain data on and off the blockchain, identity and login, and many other things. Maxthon is another really interesting project. It's a browser project, which I have to be honest, I hadn't heard of it before it appeared on Bitcoin SV and started adding support for it, but it has 670 million users, primarily in China, but I believe that they are starting to spread far and wide, and they've won numerous awards as one of the competing blockchains that's not quite in the big four, but here you can see up there top left they are actually in the big five. And so Jeff Chen, the founder, is very clear that he wants to make his browser seamlessly integrated with Bitcoin SV applications, so that you don't even need to know whether BSV is involved in the background. So I'm going to jump back again to scaling, because the scale element of Bitcoin is actually so important to what Bitcoin is. It's part of what enables Bitcoin to be secure, and it's part of what enables many of the features of Bitcoin to actually become unlocked. I'm really fond of saying that that Bitcoin never got a chance to be Bitcoin, because before rules and restrictions started to come in to limit the ways that people could use it, Bitcoin was actually tiny, and it doesn't really start to exhibit some of its real properties until it hits scale. And of course, by the time Bitcoin had a lot of users involved in it, making use of it rather, by that time, there were so many limits imposed upon Bitcoin that could constrain how you could use it, that some of those properties were never able to be exercised. So firstly, we want to talk about big blocks, big transactions, and big scripts. But firstly, I want to talk about the configuration of the Bitcoin network, because I think one of the common myths about Bitcoin is how it's supposed to operate. And the idea that everybody should run Bitcoin nodes, unfortunately, leads to a network configuration that is suboptimal, and it's not actually what Satoshi described. It leads to a mesh network, and this is the way that people mostly use Bitcoin today. You have a customer and you have a shop, and someone wants to make a payment from one to the other. The customer sends a transaction and it bounces around various nodes in this mesh network until eventually it propagates out and the shop receives it. And that has two really interesting consequences. One, it takes a long time, actually more than two. Two, the customer has no way of knowing how long it's going to take for the shop to receive it. Three, the shop has to listen to everything in order to find that transaction. And the last point that I'd like to make is that this is actually a kind of a crazy way to do it, because the customer and the shop are already talking to each other. They had to talk to each other to negotiate the terms of the transaction. So why not pass them to each other directly? But when you have big blocks, it creates an incentive for miners to get themselves well connected to each other. Because if they're not well connected, when they mine a block, there's a real risk that their block will get orphaned. And this doesn't punish the users, but it punishes the miner, because they lose the block reward. They lose all of the transaction fees that might be a part of that block. And so the first time this happens to a miner, and we've seen it on Bitcoin SV when new miners have come in not realizing how this actually works, the miner suffers a loss, and they don't want to suffer a loss anymore. And they understand that the way to avoid suffering a loss is to start to do this. The yellow ones are the miners. The miners start connecting directly to each other, because the more well connected they are to each other, the faster they can propagate their blocks to each other, and the less of a chance of them getting their blocks orphaned. And that's a Bitcoin using economic incentives in order to push the miners to increase their capacity and enable scale. Another thing happens is that miners start getting a little bit picky about who they connect to. If they've got thousands of users connected to them who are receiving all of this data, or who the miners have to send all of this data for every single block, most of that data that those users actually don't need, then that's consuming their resources. These are resources that don't offer any benefit to the miner, whereas resources put into the connection between the miners are the ones that actually create the reward for miners, or rather, they minimize the risk of miners losing reward through incentives. And the customers, as I say, don't actually need all of this data. This is part of the SPV model that Satoshi describes in section 8 of the Bitcoin white paper. And so now we move to a model where this can happen. And you note in that very first diagram, we saw that network propagating, that transaction, propagating through the network, and it took 4 or 5 steps before it got to where it needed to go. We didn't show it propagating to the other miners because we didn't have the miners identified there. But the faster that transaction gets to all of the other miners, the quicker you have zero conf or zero or safe instant transaction assurance, because miners actually respect a thing called the first seen rule, which means they will accept the first version of a transaction that they see. That's not necessarily true with BTC because they introduced a feature called replace by fee, but there's no need for a replace by fee in Bitcoin SV because you can gain complete predictability of the fees that are required to get your transaction accepted. And so this is what a typical interaction now looks like. Transaction goes directly from the customer to the shop. The shop doesn't need to listen to the rest of the Bitcoin network. They just need to maintain a connection to a miner or maybe a couple of miners, but they don't need the miner to send them all of the information. They get the transaction direct from the customer, and it's the shop that actually cares about getting the transaction confirmed. So they can establish now a direct connection to the miner, and we have tools in Bitcoin SV that enable the merchants to actually find miners and connect directly to them. They can send it to the miner, and bang, the miner sends it to every other miner in a single hop. So you should be able to get an answer to the question, is this transaction going to be confirmed, or is it a double spend, within a fraction of a second? That's possible on Bitcoin SV. Along with being able to connect to the miners and get that answer from them directly, we also have a feature that enables you, the merchant, to be notified if there is a double spend. And so knowing that there's a double spend on a network is pretty much as good as preventing it itself, as long as you know quickly, because chances are the customer is still going to be in the store. The analogy would be if you were sitting in a store, or standing in a store trying to buy a bottle of water or a can of Coke, and instead of handing over a £5 note, you hand over a Post-it note with £5 written on it. If you try to do that, the merchant's going to know immediately that, that you're trying to pay them with a very poor counterfeit note, and they're not going to proceed with the transaction. Of course, in a Bitcoin situation, knowing that a transaction is a double spend is a precise analogy of that. So let's talk about the peers now for a moment. This is the very first sentence of the white paper, and this is why I make the argument that Bitcoin intended users to be users. That Satoshi intended for Bitcoin users to be users and for miners to be miners, or rather nodes to be nodes. The word peer often gets confused as if there's only one type of peer on the Bitcoin network, but the definition of a peer is a group of parties that share some sort of commonality of status or capability or something along those lines. So there's more than one set of peers in the Bitcoin network. And here, purely peer-to-peer version of electronic cash, it's very clear that Bitcoin is supposed to be electronic cash, and also that it's supposed to be peer-to-peer. But here Satoshi describes the first type of peer, would allow online payments to be sent directly from one party to another. This is users, and this describes exactly what was in the diagram before, where we had customer and shop, and customer sending the transaction directly, without going through a financial institution. The analogy in the Bitcoin network, of course, of a financial institution is the miners, not just one, it's more than one, and that's a very important concept in Bitcoin. But two peers don't need to go through a financial institution in order to exchange a transaction. They use the financial institution for the settlement and clearance part of the transaction, but not for the actual exchange itself. And Satoshi attempted to show this as a proof of concept in the very first version of Bitcoin with a thing called IP to IP transactions, which enabled precisely this functionality. It was a very early prototype and it was missing a few things, and it was subsequently removed. But I think the fact that it was there shows the intent. Now on Bitcoin SV, that workflow that I showed you is actually enabled not just by the Bitcoin node software itself, Bitcoin D as it's commonly known, but by many other products that we've put together that make all of this simple. There's the MAPI or miner API, which enables Bitcoin users to connect directly to miners to submit transactions. There's Paymail, which is an identity mechanism that allows you to find services attached to another user. BIP270, which is an extension of BIP70, or rather a simplification of BIP70, which defines how users and customers and shops, the merchants talk to each other. Miner ID, which allows miners to advertise their identity and their services with a provable pseudonymous identity. It's kind of like the messages they leave in Coinbase transactions, but with actual cryptographic proof backed by their proof of work. And SPV channels is a very non-Bitcoiny communications mechanism that facilitates a lot of this. So you can find out a lot more about this on the Bitcoin SV website. It's bitcoinsv.io. And it's not just a home for the Bitcoin node software, but also a home for a lot of these supporting pieces of infrastructure, which are the elements that you most likely need to interact with as a developer. So I'm running a little short on time. I was worried I wouldn't be able to stretch for an hour, but I shouldn't have worried too much. So this is kind of going a little bit back over some of the old ground, but just some examples of what we've actually been able to achieve in terms of block sizes on Bitcoin SV. This is a logarithmic chart, of course, so the peaks go a lot higher. And why big blocks matter. Fundamentally, it's because Bitcoin miners need revenue in order to sustain the infrastructure of the service. And as we know, the block reward is dropping year by year. And the only way to replace that in Bitcoin is with transactions in massive volume. You can't do that by increasing the transaction fee, because that will just drive away users and it limits the pool of available users of Bitcoin severely. So it puts an upper limit on the cap. an upper cap on what is possible in terms of Bitcoin scaling. Big transactions, of course, they're important to enable a bunch of use cases that I'm sure many people think shouldn't be happening on Bitcoin. Things like Bitstagram, which I'm sure you can imagine what that is. It's a Bitcoin-style version of Instagram. WeatherSV, which records for provenance data of many other data points of weather over history in a way that's provably unchangeable, so that in future decades or even centuries, scientists will be able to mine that data knowing that it hasn't been changed. Memento is another social media platform. And of course, there's Crypto Fights, which combines online gaming with the immutability of Bitcoin. One really interesting use case that I want to show you is something from a company called EHR, who are primarily concerned with healthcare records in the United States, and they're particularly attacking the opioid crisis. And without going into too much detail of the system, they envisage Bitcoin. They envisage making use of about 3.2 million transactions per day initially, eventually rising into the billions. But this is just for opioid prescriptions. And in order to get all of the historical data onto the blockchain, just showing a few quick metrics in terms of how long it would take to do that. So with the current block cap on Bitcoin BTC, it would take about 44 days to get that data in. With Bitcoin SV right now, given the current capacity, you could drop that down to 32 minutes. And of course, once we get to Bitcoin Teranode, that is going to increase dramatically. And the last thing I want to touch on is Bitcoin scripts, because this is really the capability of Bitcoin that has been lost to us for so long. This is a long Bitcoin script. And here's something that it's not necessarily the same code, but it's an example of Ethereum Solidity. But this is what people tend to think of with Bitcoin script. It looks very much like assembly language. It's utterly horrible to read, to look at, and trust me, it's even worse to try and code in it directly, especially with the tools that are available. But that is changing on Bitcoin SV. Over here on the right-hand side, we have a language called script, which looks very much like JavaScript. And this actually will compile down into a Bitcoin script, which you could liken to the bytecode, much like what sits behind Solidity. So script is available as a Visual Studio VS Code extension, as well as in its native form. And here is an example of some of the functionality that you can do with Bitcoin scripts. This is very similar to an opcode that other blockchains have introduced called DataSig Verify, or check DataSig. It basically allows you to put data into a Bitcoin script and have an oracle sign it and verify that signature to prove that it actually came from the oracle. And it's not the only one. There's many smart contract languages that are happening in Bitcoin SV. So I've run out of time here, so I'm going to draw this to a close. I think possibly there might be a question or two, but I might defer to the guys to say whether we can take any questions or go over time a little bit, or whether we need to wrap it up. Okay, I've got a couple of questions here, so I'll go until I get the signal to wrap it up. Okay. Is the fact that a blockchain landscape is that fragmented also a fact which inhibits public acceptance? I think that's probably a fair point. It's probably very confusing for people outside of the Bitcoin world and the blockchain world in general to know where to go. But the answer to this, I think, is that you present users with a way of making use of blockchain without them having to make that choice. and probably without them even having to know what blockchain is in the background, or even whether there is a blockchain in the background. I don't think Bitcoin is going to achieve mass adoption because Bitcoin is cool and people want to use stuff that's got Bitcoin in it. I think Bitcoin is going to achieve mass adoption because it solves problems for people. And whether they know that Bitcoin's there in the background or not doesn't really change the fact that it can solve problems for people. And it has a lot of properties that are unique that can't be solved by any other technology. And this is part of the reason why I think scale is so important. Is not storing data on chain against a cache system fundamentally? I don't think so. I think you would argue that it would be anti-cache system if it prevented the cache system from working as well as it could. I think if using data on chain was going to choke the network somehow and it decreased the utility of cache, then yeah, you would argue that that's a bad idea. But as a technical director of the Bitcoin SV project and as a person primarily responsible for Terranode, it's my job to make sure that doesn't happen. We need to keep the supply well ahead of the demand. And Bitcoin has the incentives for people to do that built into it. So in fact, it works better when you add more and more use cases to it. Someone asked, can we receive the slides for this amazing talk? I can't see a reason why not. I'll talk to the organizers of this event afterwards and see what we can do about that. Is it possible to create a kind of mesh network on an incentive basis? And are there already such approaches? It probably is, but I'm not entirely sure why. A mesh network is useful, I think, when you have a large number of participants that all need to share a common amount of data, but a common set of data. But it has fundamental problems with scale. You can propagate things across a mesh network and they will take time. But some of the properties of Bitcoin actually need fast propagation. So it's not very suitable, I think, in a Bitcoin context. Okay, so I'm being told all questions that are not answered or will be forwarded to me, and yeah, I will endeavour to make written answers, which probably can be made available on the WeAreDevs website. And if we end up with some spare time later today, I'll try to answer some more. I'm really happy to talk about Bitcoin from a technical point of view. There's as I say, there's some controversy about Bitcoin SV, but when you actually sit down and talk about the technicals, it's just a blockchain, and it makes sense for a ton of reasons. And the challenges, I think, that people tend to get hung up about with Bitcoin scale are ones that have really easy answers, which I always relish the chance of giving. So I'm going to wrap it up here now, and I think we're going to take a short break before we get to our next speaker. So thank you. Next up, I'd like to introduce Professor Tim Weingartner, who's a lecturer at the Lucerne University of Applied Sciences and Arts, Lucerne being one of my favorite cities in Switzerland. He's working on blockchain technology and some of my favorite subjects, applications in IoT, identity, and the energy sector. So here to give us an introduction to smart contract fundamentals and his first DApp is Tim Weingartner. Thank you, Tim.
Thanks, Steve, for the introduction, and hello, everybody, and welcome to my presentation on smart contracts fundamentals. So this presentation is meant for the beginners of you who are curious about blockchain development and smart contracts and decentralized applications. So we'll start with some theory and then directly dive into development. I assume that all of you have some fundamental development knowledge and also some knowledge about blockchain. But nevertheless, I would start with some features of blockchain, which are, from my point of view, important to know. So as Steve in his presentation already mentioned, blockchain is immutable. So it's an immutable database, a write-only database where you can write your data in and then it stays there forever. Another very important feature is the distribution. So this database is not only on one computer or on two computers, it's distributed over a lot of computers. So therefore, we have security aspects and also failover systems. Beside immutability and distribution, transparency is one of the major aspects of a blockchain, especially for public blockchains like Bitcoin or Ethereum. Transparency over the data in the blockchain also gives trust to all its users and participants. To write something into this database, we need to have a consensus between all the participants, between all the nodes. That's very important so that we have one unique view of this data. And there are several consensus protocols like proof of work, proof of stake. I don't want to go into detail here. What's important is to be able to write into this blockchain, we have to form some kind of consensus to follow some rules. In the blockchain, we are anonymous. Let's call it pseudo-anonymous. So we are not working with our real names, but with an address. But pay attention, once this address or the connection between the address and your name is done, then this anonymity isn't guaranteed anymore. And the final features most of the blockchains today have is its programmability. And here we are with smart contracts. So yeah, what are smart contracts? First question. And if we go into the definitions that are around in the web, we find a lot of definitions. The first one is from Nick Szabo from 1994. A smart contract is a computerized transaction protocol that executes the terms of a contract. And you see, this definition was made long before Bitcoin existed, long before Satoshi Nakamoto wrote his paper. So it doesn't really strictly related to blockchain, but with the rise of blockchain and Bitcoin, a lot of new definitions came up, which all include blockchain or decentralized distributed applications in its terms. So I don't want to go through all of them. I put together one own definition, which is more broadly. So from my point of view, a smart contract is a pre-written, tamper-proof, and unalterable computer program representing a legal agreement or act of legal significance between two or more parties. What's important in this definition is the smart contract is pre-written. So it's written once and then tamper-proof stored on a blockchain or distributed ledger. So it cannot be altered anymore once it's deployed. And it's somehow linked with some kind of legal action. To the features, a smart contract is, as I mentioned, stored and replicated and self-executed on a blockchain or distributed ledger. In order to be self-executed, this has to be triggered by some kind of digitally verifiable event or condition. And what's very important, and which is used also for the cryptocurrencies and tokens, it can take custody over and instruct transfer of blockchain entitled assets. So it's something about value, it's something about assets on a blockchain a smart contract can act with. But why does smart contracts matter at all? Why do we need smart contracts today? What's the reason for not just developing in other languages on our usual environments? For this, I want you to step into this kind of vision of the world today. So on the one hand side, we're in this physical world where time is linear. We are at one place. We can touch each other. On the other hand, we are all involved in this digital world. You're now listening to this presentation, perhaps live, perhaps since it's recorded, you listen to it tomorrow. So time doesn't take this role or this linear role in the digital world than it does in the physical world. Also, location is not so strict as in the physical world. We all learned this during this pandemic and moving home and working from home. So virtually we came together, but physically we are in different locations. And what's very important to understand is that everything that's in this digital world is easy to copy. It's easy to copy. It can be faked, like those images onwards. And that's a real problem, especially if it comes to real world assets. So if you want to bring real world assets to the digital world, we need some kind of trust system, some kind of system that gives us uniqueness, because uniqueness also defines its value. And here smart contracts come into action. So yeah, that's for this short introduction and the theoretical part. Now let's step into coding. And I prepared 3 examples. We start with a simple counter example, then go up to money, creating our own money, and then going to games. I pre-recorded all these actions, so I don't have to switch the presentation, but I just will command it. So first of all, we need some kind of development environment, and I would like to introduce Remix at the Ethereum blockchain for you. That's an development environment which allows us very easily to develop our own smart contracts. So I just prepared a small counter contract, and that's pretty easy to understand. We have one variable, we have 2 setter functions, one to increment this counter and one to decrement the counter, and we have our getter function. Important with Solidity, and that's the language we're dealing here, is the first line, which represents or defines the Solidity version we want to interact with. And since Solidity is still under development, we have a lot of versions, and also the code base will change on it. Now in Remix, we have the possibility to compile our contract and then to publish on a blockchain. For this, we have several environments, a local JavaScript virtual machine, and this machine, just stop it here, this machine gives us a set of addresses and also Ether, so money to interact with the blockchain on these addresses. So this is not real money. It's locally, and yeah, you can't pay on the normal Ethereum blockchain with it, but it's just to help you to deploy a contract, since you need some kind of money to deploy a contract and to interact with it. All these transactions are paid with gas, which is a fraction of Ether. And now I've deployed our contract, and you can see here the details and also the costs for this deployment. Once our contract is deployed, it's on the blockchain, it gets an address, and we have several buttons here to interact with our functions. We have the two orange buttons for increment and decrement, and the blue one, the getter function. So when I just press this, I get the actual value, and that's 0. Also here to mention, the orange buttons, they cost something. So each time I write to the blockchain, I alter something on the blockchain, I have to pay for it. The getter function is free if I'm not a contract. So if I increase the counter, then it's 1, it's 2. And on the bottom side, I see all the transactions, all the transaction details, and also, again, the costs for this transaction. As mentioned before, if I use the get counter function, these costs only apply when I'm a contract, but not when I press this button. Important, if we interact with this contract, we need this address, which is given by deployment. And as mentioned before, we just worked with the local JavaScript virtual machine, but we can also use a wallet like MetaMask to interact with it. And we also can change the blockchain to one testnet or the live version. With the button on the top, we come to the description. Here you will find more detailed introduction into the whole environment, also some sample contracts and some information about debugging. So yeah, if I recommend really to go to Remix and take your first steps there. That's pretty easy, and you don't have to install anything on your computer. So yeah, that's the first part, just to get our first contract alive, to get some feelings about the development environment or the language Solidity. But if we want to build up more complex contracts, we need some kind of environment. And for this, just switch to another development environment, and I would like to introduce you to the Truffle Suite, which is also available on the trufflesuite.com, which has several applications, and the two which are important for now is Truffle, the compile and deployment program. That's a console-based tool for us to compile and deploy a contract, and Ganache, which gives us a local blockchain. As before, we get several addresses already with a balance, and we can interact with this blockchain, which runs locally on our computer. So you can download this and install, and afterwards you can take the contract, just the same contract as before. Now we have this kind of file structure, and let's just stop on here. We have on the one hand side our contract, our counter contract we've seen before, and this migration contract, which Truffle installs on its own if you set up a project which allows to migrate contracts and redeploy contracts on the blockchain. What is very important if you work with Truffle is that your setting in the configuration correspond to the settings in your Ganache, so that you're really connected to the right blockchain. And on deployment, you really put your contract on this blockchain. So yeah, that's the contract side. And on the other hand, we want to interact. We want to interact with a web application. And I put together here some kind of small front end. Just as before, we have 3 buttons, an add and subtract and a get counter button, and also a short display possibility for our counter. I packed all the interaction stuff code for interacting with Ethereum in this JavaScript. And we strongly rely here on the Web3 library. And yeah, so let's just start it and start our web page. And now we need some kind of wallet. And here's the first mistake a lot of people do. If you start it locally and you try to connect your wallet, MetaMask, which can be installed in the browser, with your HTML file, then you get a problem that it cannot connect. So pay attention. You have to start your application in a server environment. So you have to start in a web server. Some development environments give this with the environment. So let's just start this in our localhost server. And now when we go to MetaMask, we can establish this connection. Just some words to MetaMask. MetaMask is an add-on. You can plug in. You can install it on your browser, and it gives you a wallet. So wallet is comparable to what you have a physical wallet. It stores your access to a blockchain. It stores the accounts, so that's the addresses we see here. Also in Ganache, that's the public address, and also the private address. That's the key for this public address, which guarantees that you are the owner of this address. So the private key shouldn't be shared with other people's, and this private key is stored in the wallet. So it might seem that the wallet holds your money or your Ether or token, but it just displays them. It only stores the public and the private key. The amount of Ether, for example, is stored on the blockchain. That's very important to keep in mind. So this wallet has to connect to your blockchain, and then it can interact with it. So all the actions which we do in our web page go through this wallet. All the actions are signed by the wallet, And now we have the same functionality as before in Remix. We can get our counter. But now if we want to subtract, for example, which costs Ether, our MetaMask will display this transaction. So this account, which is set up in a MetaMask, wants to call this contract, and I have to confirm this in MetaMask. If I don't confirm, this action will not be executed. So here we have our counter address on our blockchain. And if I confirm it, the transaction goes to the blockchain and I subtracted 1 from our counter value. Can do this again. The same if we add something, we have to pay gas for this action, and afterwards we can get our counter. Just let's switch to this JavaScript. I mentioned that this interacts with our Web3 library. First, we have to detect MetaMask. Afterwards, we have to establish a connection to our contract. So there it's important that we use the correct address. We also have to set up the ABI, that's the application binary interface. But don't worry, during compile time, Truffle will set this up and store it in the build directory. So you don't have to type this by your own. Then we have to get our address, because this address we have to provide for all the transactions. And then we have our 3 functions. So the 2 setters, which uses the send method. And here we have to provide the account, because this account has to pay for it, for this transaction. And for the get function, we can use the call command. And here we don't have to provide money or Ether or gas. The result is then displayed on our web page, and so that's pretty easy version of our counter. So we now have built up our contract. We deployed it on our blockchain running on Ganache, and we have our front end which interacts with this. So let's go to the next part. Let's build our own money. So you all heard about cryptocurrencies, and I mentioned before, MetaMask holds our Ether, or it holds the access to our Ether, but also can hold the access to tokens we created on the blockchain. I can add new tokens in a MetaMask, and here I created an HSLU token. And when I have this token, so different accounts have different balances of these tokens. And with MetaMask, I also can send tokens from one account to the other account. It's like sending Ether. So I have to select the account that sends money or sends token. I have to tell how many tokens I want to send, and then I have to confirm it. The transaction now gets sent to the blockchain, confirmed on the blockchain if I have enough balance, and then I have transferred token from one account to the other account. And that's the same if it's on a local blockchain or if it's on a live blockchain. But you cannot transfer tokens from one blockchain to the other because the token is strongly related to a contract. So this brings us to the question, how does this token is defined. And here I would like to introduce the ERC20 digital money token. So as mentioned before, the token is a smart contract. So each token, each individual token is one smart contract which hold these tokens and also holds the transfer between actors or accounts. ERC stands for Ethereum Request for Comments. And you can think of this like a standardization of the token contract or the smart contract. And this ERC was introduced in 2015. And when you look at Etherscan at the live blockchain today, we have around 300,000 of those ERC20 tokens. So pretty a lot of tokens which have been generated. So let's have a closer look on how this digital money works, or how the program behind it works. So the main part is this mapping. This mapping, you can think of a structure which references each address, its balance in this contract. And at the beginning, the address or the owner of this contract, so the address who deploys this contract for the first time, who calls the constructor, gets all the tokens it's generated. During this construction, you can define how many tokens are generated and the name, how many decimals they have, and the symbol. So after the construction, one address has all the balance, all the tokens, and afterwards this address can spend or transfer tokens to other addresses. And after each transfer, the new balance is held in this structure, and that's all. It's like a structure that holds the balance, and that's the token system or the smart contract that's behind it. One important part in this program or contract is the improve and allowance functionality, because I don't want to use this contract not only between persons or addresses which act from outside. I also want tokens to be handled by other smart contracts. And as the security measure, if I want to allow a smart contract to take my money, to act with my tokens, I have to approve a certain amount or allow a certain amount of those tokens to this contract, and afterwards the contract can transfer tokens as long as it's below this amount. So that's pretty important to understand. So therefore, if I want to transfer something, I first have to approve a certain amount of tokens, and afterwards I can initiate the transfer. And that's all for digital money. So that's pretty easy to create your own tokens, your own money. But remember, it's just virtually. So yeah, there's not any value behind it as long as you don't guarantee that for one token, for example, you can buy something in the real physical world. So finally, let's go into gaming. And I just want to show you how the stuff we learned so far can be used for a pretty simple game. And I have to give the credits to my daughter, who did this in her Matura-Arbeit. So we have a contract that plays tic-tac-toe, or it doesn't play it. It's the contract who holds the rules, who holds the amount of money, so your stake you have to put in order to be able to play, who holds the actual status of the board, and also who decides who wins. And so we have two players, both have to put in stake, so a money or token. Then afterwards they can play, so they can tell the contract which field they want to put in their sign or their sign. And when one of the players wins, so you have 3 in a row, then the contract will pay this player all the money which is in. If it's even, so if you don't have a winner, then each participant gets back his money. And I would like to show you how this looks like. As mentioned, we need some token. Here we have another token, which is the country token. That's similar to the one we created, ERC20. And if we want to play, we have to confirm that we want to spend 0.1 token. And afterwards, we have to confirm the transaction. And this transaction is now propagated to the blockchain. And then I'm the first player, and I have to wait for a second player to play with. Just fast forward. So if we have a second player who joins us, then the contract will decide who is on. So my opponent set the first field. Now I can act and set my circle in a field. Each action is transferred to the blockchain and is registered in the smart contract, so nobody can cheat. Now, so the game goes on. As mentioned, each transaction has to be confirmed. And to make it more interesting, my opponent is not the cleverest one. So he or she makes an error, and I can finally get 3 in a row. I have to wait until this action is confirmed on the blockchain. Fast forward here. And now the contract detects who wins. The contract knows the addresses of all the 2 players and sends the money to my contract since I won this game. So yeah, that's pretty easy a game, and so I showed you in 3 different parts, in 3 contracts. First, how a contract works with the counter, then how I can create my own money, my own token, and how I can use this for game. So you now might say, well, why do I need a smart contract? I can do this on a server platform. And that's true, and that's more efficient, and no doubt. But I have to trust the server platform. In this case, I trust the blockchain, which is run by a lot of people, and nobody can cheat. And that's the very important part here. And also other use cases which use smart contracts all rely on this. What's very important to understand, and you also have seen it in the definition at the beginning, once a smart contract is deployed, I cannot change it anymore. So if I make an error in my contract, it's done. So it's deployed and people can use it. And if I put money on the contract, in the contract, and I have errors, then this money or these tokens are gone. Therefore, you have to really pay attention, and there are several services on the web to help you to prove your smart contracts. For example, Securify, that's a startup from ETH. They recently got acquired by PwC. they have an online service, and they also make audits for contracts to show you where are vulnerable areas in your contract, and yeah, to help you to don't make errors in there. So yeah, really, when you act with smart contracts, pay attention on this. And there are some other challenges beside code correctness. Also, as I mentioned, if you have an error in your code, you cannot change it afterwards. And you perhaps have heard of the DAO hack, which is a smart contract or several smart contracts which organize a decentralized autonomous organization. And there was a vulnerability in one of the contracts, and somebody could get tokens out of this contract. And the only thing we can do is we can reset the blockchain. And in those days, it was possible. There was some discussion about this kind of fork where you reset or set back the blockchain. But normally today, you are not able to do this anymore. Also, as we mentioned, since smart contracts are blockchain based, they depend on scalability and performance of this blockchain. And also one problem you can come across if you are dealing with real world objects or real world assets, the tokens in smart contract can controlled by smart contracts, and you can guarantee the immutability of these transactions. But when you deal with real world objects or assets, then you make a link between, for example, the token and a real world asset. And here in this link, which cannot be stored in the blockchain, there is a problem which is called Oracle problem, and that's part of a separate lecture. And so since smart contracts give us the control over assets, tokens, and if those tokens represent real world assets or money or other kind of values, again, you have to pay attention on errors. So with this said, I hope I make you eager to learn more about smart contracts. You try it out on yourself. I just put you here a link to a page which we set up, some kind of learning environment we also use in our lectures, blockchainworkbench.com. So have a look at this, have a look at the other tools I showed you. And yeah, I hope I could show you some aspects of smart contracts, and would like to, or I'm open for questions now.
Thank you, Tim. We've got a few questions here, and we've got a few minutes to run through them. So I will begin. The first question sounds more like a comment. Someone says they love your definition of the smart contract. It could really help out with our digital twins. But on to the first question that looks like it's really a question. Can you explain the relationship between gas and ETH itself?
Yeah, so the gas is just a fraction of ETH. So as seen in the remix, it's a 0.000 something. You, in order to act or deploy a smart contract, you really have to buy Ether, and with these Ether, then you can pay the gas costs. So each transaction have to costs you gas, some kind of fraction of Ether. And since the price of Ether is rising at the moment, so also the gas costs are rising when you compare it to real money.
Okay. Is there any kind of adjustment mechanism between the two of them, or is it a fixed relationship?
No, it's a fixed relationship, and the gas costs are calculated by the complexity of the functions or the contract, and that's the share who goes to the miners who are responsible for the proof of work at the moment at the Ethereum network, and also for storing all the smart contracts. So yeah, you can think of yeah, giving money to them that they run the environment or infrastructure you run your smart contracts on.
I see. The next question I think you probably answered in your last slide, which was where can we find a list of developer tools and resources to get started?
Also, I showed some of those tools. We can also share them afterwards in some comments or something. So I would really encourage you starting with Remix, because that's online. That's pretty easy to get some first hands-on sessions with Solidity, and afterwards then switch to Truffle. So that's for the Ethereum blockchain. Other blockchains have other development tools, so it really depends also on the blockchain you're acting with.
Okay. Someone's asking what benefits I get from using a private Ethereum blockchain and what would it cost, asking for their Matura project.
So yeah, using a private blockchain is always the question, why use a private blockchain? You can just use a database. So the only benefit using a private, or let's call it permissioned blockchain, is that you have some kind of ecosystem, that kind of participants, especially in industry, where, for example, several companies together work on one topic and want to store this because perhaps they mistrust each other. If it's just for yourself, it doesn't make sense for production. It makes sense, as I showed you, for get into touch into smart contracts, to learn about smart contracts. But the real benefits comes from acting with a public blockchain like Ethereum, when you deploy your contract onto the mainnet, or if you have some kind of consortia and act in this consortium.
Yeah, I suspect the topic of public versus private blockchains is going to be a hot topic of debate over the next few years. So Anonymous asks, can we create our own DApp without creating our own token?
Well, sure. So as I showed in the first example, the counter example there, we don't have any token. We can just deploy the contract. We can set up our DApp, which was this HTML with JavaScript program, which interacts with the contract. It makes sense to introduce tokens then if you introduce some kind of representation of value.
Okay. And someone is asking what is Crypto Valley? I saw it in your slides.
Well, Crypto Valley is here in Switzerland. It's the region around Zug and Zurich. It was called Crypto Valley years ago when several crypto or blockchain companies set up their bases here. So, for example, the Ethereum Foundation really settled back then in 2015, I think it was, in the Crypto Valley. And so this term was created, and it also got recognized worldwide, since there are several initiatives here in Switzerland. Also the city of Zug, which is very active in the crypto area, which has provided their own e-identity on a blockchain base where you can pay your tax now with Bitcoin. So yeah, we're pretty in crypto here. Yeah.
I've been to Zug a few times myself. It's a lovely place, and certainly a good spot to be if you're into cryptocurrencies or Bitcoin. So another local question: what types of courses does your university offer that relate to blockchain?
So we're University of Applied Science. So we have the normal bachelor and master degrees, and we also have continuing education programs. So Certificate of Advanced Studies, for example, there we have several courses on blockchain for people who are already in business and want to improve their knowledge. And for our students in the bachelor degree, we have several blockchain courses, some fundamental courses, also development courses, and also hands-on courses. So I just had in September one course together with IBM and Zebra, where it goes around Hyperledger and combination of blockchain and IoT, for example.
Okay. I think IoT's got a fascinating future when it's connected to blockchain. We've got a comment here from Status who says that the blockchain workbench is really interesting. Please try it out. I'm in section 4 and it feels like it's getting me on track. Another one that's just popped up. I'm searching for a creative idea so I can construct a DApp based on Ethereum blockchain for my diploma thesis. Can you suggest something as creative as tic-tac-toe? Have you got any hints for thesis?
Well, it really depends on what your thesis, in which direction it goes. So do you want to go in some kind of gaming? Then you really have to think of why should I use a smart contract? So can I introduce some kind of value or money into it? I think other really important or nice use cases go in the direction of supply chain. We see it more and more, tracking of goods through different stages of the supply chain, for example, or some kind of contracts which represent legal contracts, for example. So if you want to sell some goods, or you have some kind of escrow contract where you lock in money and then sell goods for this, that would be nice and interesting use cases. Or if you want to go into identity, self-sovereign identity is a real new topic, and there are several use cases for smart contracts here.
I might suggest online chess as an alternative. If you don't like doing intelligence tests, you can collect your history of chess playing and feed it through an algorithm too.
Yeah, but you have to pay attention that you shouldn't make the contract too complex, because then it costs pretty much. So you don't want to really have large applications, large contracts, really reduce it to a minimum.
Yep. You talked about ERC20 before, which I believe is actually a standard presentation format for a contract. Can you just explain what role the ERC20 plays in the ecosystem, and is it actually a token itself?
Well, the ERC20, as I mentioned, is some kind of standardization. So it was this implementation of this contract was proposed to the community. There has been changes. It went through acceptance, and then you finally have this kind of specification. And so most of the tokens, fungible tokens, where each token has the same value or same meaning, use this ERC20. There are several derivatives from it, also additional implementations, but most of the tokens, also tokens which the famous ICOs, initial coin offerings, rely on, are based on these tokens. And the other big token family, you can call it ERC 721, non-fungible tokens like CryptoKitties. So each token has a different meaning, a different value. So these two main token families you can distinguish.
Okay. Well, we're approaching time now, so we're going to pop to a very short break before we come back for a panel on the intersection of business and technology of blockchain. So I'd like to thank Tim very much for his presentation today, and I will probably run into you somewhere in Zug or CERN at some point. I look forward to that.
Thanks a lot, Steve, and thanks all to the audience for listening to my presentation. So see you. Bye-bye.
Thank you. And now it's time for a panel discussion with a few innovators in the blockchain space, and we're going to change direction a little bit here and move toward the business end rather than purely the technology end. And the title of this panel is "Can Blockchain Change Business? How and Why?" Joining me today, we have Paula Petit, who is a serial entrepreneur who's exited her first 2 startups successfully. And I can't tell you the number of startups that I've seen that compare to the ones that actually exit successfully. So that's no small achievement. She's been in the blockchain for the past 3 years and began her journey by co-founding Bitfact, which is a portfolio management tool acquired by Shapeshift. So that's one of the big players in the blockchain space. And now working as head of business development at Linum Labs or Linum Labs?
Linum Labs.
Linum Labs. I still haven't resolved the argument about whether it's Linux or Linux, which is a global blockchain consultant and development company. And I'll come back to her in a minute to ask for a bit more background. David Case is the chief architect of Chronoverse, who you actually would have seen mentioned in my presentation earlier. They're building a platform to bring blockchain gaming to the mainstream with the first release, Crypto Fights, and it's currently in open beta, so you can get in and play it. I've had a crack at it. It's actually jolly good fun. And they've been building on Bitcoin SV since just after the fork, the Bitcoin Cash fork. So I will jump back to Paula and just say, can you tell us a little bit more about Linum Labs?
Yeah.
And what you guys actually do?
Yeah, so we're a blockchain web development agency. So we consult companies on anything that they want to develop related to any blockchain or smart contracts. And we can create quick proof of concepts for them or like a full scale solution. And yeah, we work with all size companies, whether it be like an enterprise company trying to dip their toes into the blockchain space or just a brand new funded founder who needs developers and help to get them off the ground.
Okay. And David, for everyone else's benefit, because I already know, but can you tell us a bit more about Chronoverse?
Sure. So Chronoverse is, we're I guess, kind of a gaming platform as well as a gaming studio. And we started our company actually building the Crypto Fights product. Well, we started building Crypto Fights about a year before we started the company, actually. And Chronoverse basically aims to provide a platform that developers can easily work within that gives them access to fiat to token conversions and automated agents that interact with actions that happen along the on the blockchain, as well as tokenized standards for game items such as weapons and armor and fighters and things like that. And so we're working both on developing the first game on the platform at the same time as we're developing the platform out.
Okay. And for all the real nerds out there like me, it's based on a particular type of die that only the nerds will recognize. Which one is it?
It's the battle system is very Dungeons and Dragons based. So
the D20 system. Yeah.
Yeah.
Okay. So Paula, I'll jump to you first. In your position, I imagine you talk to a lot of people doing a lot of different projects, potentially even on a lot of different blockchains. Do you foresee a world where there's going to be many competing blockchains, or do you subscribe to the idea that one is eventually going to kind of become dominant?
I guess it kind of depends. I mean, I feel like the ideal world is either one, blockchain that, anybody can work on. It's become very standardized, or we've created a way for blockchains to communicate really effectively with each other, that then it doesn't really matter if it's built on different blockchains. I think the world that's going to happen in the future will depend on like what companies do, because right now we do have a lot of different enterprise companies building their own internal blockchains, which I do think goes a little bit against the overall mission of blockchain to create kind of a, one transparent place for, all kinds of players to come in. But I do think there is going to have to be some form of communication. I don't think there's going to be multiple major blockchains that can't communicate with each other. I think there will be one or a lot of interconnectivity.
Yeah, interoperability is actually one of the words that I probably use more often than any other in the office. I can see people's eyes glaze over sometimes when I drop that word in a sentence, but I tend to agree with you. It is actually one of the fundamental services that a blockchain can provide.
Mm-hmm.
Common interface, potentially common data storage format, or at least data notarization format. Yeah. So David, I want to jump to you and challenge you a little bit on the value proposition of Chronoverse, or rather the games that Chronoverse creates and builds. Why should I use a game that's attached to a blockchain over any other one? What makes it better?
Well, essentially, what makes it better is every bit of data and every bit of state within the game is all connected to every other bit of data and state in the game. And you end up with kind of a fully auditable history of everything that's ever happened, but in such a way that like state changes within a game, a person taking their turn that, I don't know, attacks someone or whatever, that reflects, I mean, that actually points to where on the blockchain the fighter is defined and what it looks like. And that points to everything it's done in the past. And when it comes to your weapons and armor, you have like full history of everything it's ever done. So rather than just like sitting down and playing a session of a game, as time goes on, you end up with the entire history of everything that's ever happened. And so when you like read fantasy novels and they talk about like this sword that has, whether it be Sting or whatever from Lord of the Rings, like this sword has a history, and it was created it was mined by or smithed by dwarves, whatever, years ago. And it's had all this history of these different activities that it has been part of. And we kind of can bring that to gaming now, such that things can evolve over time and you have full access to the lore of the item. And so when you have maybe a place to buy and sell and trade items, like it isn't just like, okay, here's this sort of truth. This is the one that won this tournament in this year and achieved all these achievements on this quest. And like, you can build in the entire history of everything that's ever happened, and everything is tied to everything else. So it's a very full and complete picture of the entire history of your gaming experience.
So I can imagine a very rich collector market building up on top of the history like that.
Yeah. And then additionally, I mean, you can do cool stuff where as these items are defined and owned by the individual, gaming can actually kind of change that some new game developer can come out and say, okay, CryptoVites has this mechanic that works well, and people have these items that have these type of properties. Let me build some other type of game that can interpret CryptoVites items. And then those items can, I don't know, I mean, basically you can start having this intertwined mesh of not just one gaming world, but it really leads toward the whole like interconnected metaverse of, it's like a whole universe of data for all the games that are built on it, and they can all point to each other's history and each other's rule sets and use those. And when it comes to like modding in the game space of like people coming up with new ideas to tweak a game that's already out there or create a new style that uses things from across the universe, those doors are wide open as well. So
it sounds like there's going to need to be a game attribute standard, as in how do I translate +7 to hit on a D&D sword into some other game with a different system.
Yeah, and I think that those kind of things will evolve. There'll probably be many of them, actually. Like we're probably a long ways off from there being one universe that everyone builds within, but I certainly can see lots and lots of different parallel universes where different shards of logic are all kind of separate from each other, but they've got their whole standards built out that, yeah, I think there'll be lots of different standards that come up, but I also think that's a little ways away still.
Yeah, that would be exciting to see it unfold. Paula, without breaching any client confidences or NDAs and such thing, can you give us an idea of some of the types of projects that Linum consults on?
Yeah. So yeah, a lot of them are under NDA, but one of our easier to explain ones is when we did some work for the Swiss Railway, and we helped them create basically an identity verification on the blockchain for railway workers. So there's all these different railway work companies that come and build on the railway, and if anything goes wrong, they need to be able to track and see who was there, you know, from a very decentralized point of view. So we created, using Uport, basically a system where where railway workers could go get their identity, and you know, it can be verified quickly that they're verified to be there, and at that point it is saved on the blockchain. So if anything does go wrong, it can be easily tracked, and you know that it has not been tampered with. I mean, a railway crash is a pretty big deal, hypothetically. There would be incentive to change that data. So this creates, you know, a tamper-proof application for it. And yeah, so we you know, partnered with them to, you know, go live with that prototype.
There's an incredibly strong appetite out there. I mean, when you talk about applications like that, often people say to me, well, why do you need a blockchain for that? Why not just put it in a database and store it with the government department? One often wonders, why would the government department themselves not be happy with a solution like that? Because surely they can trust themselves. But it turns out they're more worried about other people not trusting them. And so, yeah, I see a huge appetite for this unalterable data, because it just makes it so much easier to trust. So I'm going to go a little bit more generic now. I think everybody involved in blockchain, and I'm going to try and use the word blockchain because I know this is not a Bitcoin specific event, but occasionally I will let it slip. So forgive me if I do. I think we all have an interest in seeing it explode and achieve kind of mainstream adoption. And what that means can be many things. It might be that everyone is using blockchain in some application without necessarily realizing that it's there in the back end.
Absolutely.
What key pieces of infrastructure do you think that we're still missing in order for it to really hit the mainstream and serve 7 billion people?
I still think there's just the knowledge that is still very much lacking on a very large industry scale. You know, executives at big enterprises are still a little bit in the dark of how this whole thing works. Sometimes it's still attributed to, you know, more darknet behavior. So there is definitely knowledge, but there's just a couple other things that are still holding it back from explosion. The standardization, I think, is one where it's just easy for companies to come in and build off of it. I think there's still a lot of compliance questions because this industry does move so fast. A lot of people still don't know what they can and can't build, but I'm sure that'll mesh out in the next couple years. And then scalability, I think there's still just you know, some scaling issues that happen with the blockchain. We're all aware of them, but again, I do think that's something that's going to be sifted out in the next couple of years. That's technology. You know, 10, 20 years ago, you needed a whole room to store something that you can now store memory on like this size. So I don't doubt that that's going to come around, but I think the compliance, standardization, and scalability are like the main missing pieces right now.
Okay. I'm going to throw the same question to you, David. I'm going to guess that you're not going to worry too much about scaling.
No, scaling is not really my concern. I think the big thing holding blockchain adoption back right now is simply just getting into it, being able to buy whatever coins or tokens it is that work within your world, and having simple identity validation. That's getting better and better all the time, but just getting people into that world. At the same time, I mean, our platform is largely a user doesn't even know that they're running on a blockchain, except for the marketing buzz that we might put around it, or that the games might put around it. Where, I mean, essentially in our platform, I mean, people deposit fiat with us through a normal payment gateway, and then everything is like tokenized in the background and lives on the blockchain in the background. But that's pretty much transparent to the user. Their gameplay experience doesn't rely on knowing anything about how the blockchain works or anything. And so I think from a wide adoption standpoint, still getting people in is a big hurdle. But at the same time, I think there's a lot of solutions that are starting to come to utilize this technology without making a person know that they're holding on to some asset and worrying about the fluctuating value of that asset or whatever.
Yeah. I think this is actually a really well-recognized problem, particularly in the last couple of years. I've noticed people starting to talk about it as they're actually trying to build applications for people who are not Bitcoin or blockchain obsessives. They're trying to bring in normal people, the other 99.9%, and that's where this kind of onboarding challenge really starts to get highlighted. But I have been really glad to see a lot of creative thought being put into it, and some solutions that quite frankly blew my mind the first time I heard them. One interesting one actually is an application called BitPing, which mirrors the type of service, a service called Uptime, which can monitor websites, but it actually makes use of end user devices. And so these end users actually just can install this app and send out random pings to different websites, and suddenly they're getting paid tiny amounts, but it builds up, and eventually it's enough to be able to make some tips on a social media site or something like that. But that's just one example, I think, of the creative thinking that's going into how to actually get people attached to the blockchain in some sense, and just having a wallet is often a starting point. That's a big hurdle for a lot of people. So, Paula, I've got a question from the audience for you. Someone piqued someone's interest about the Swiss Railway. I've thought about this example on Swiss Railway. How is it implemented regarding personal data of workers? So I think he's asking about how do you protect personal data, GDPR compliance, and that sort of
Yeah, so it did turn out it is a GDPR compliant solution. So the owner of it could verify, the owner of the data, they're always in control of it, so they can decide who gets to see their information and when. And it can also be verified anonymously if it needs to. That comes in with blockchain. You can verify while still protecting the data. So it could go either way. It could be shared anonymously, or they could just decide to share it with whoever was inquiring. But they, at the end of the day, still got the last say.
Okay. And this is what I've wrestled with a few times myself. I've got a couple of ideas, but right to be forgotten, that almost sounds like the antithesis of blockchain. It's once it's written forever. It can't be changed. It can't be deleted. How do you address that sort of issue?
What do you mean exactly? I guess once it's written, it can't be deleted. I guess what's the concern here? Sorry.
The right to be forgotten. I can't recall if that comes to you.
Gotcha.
Yeah, it's certainly something that's part of recent regulation whose name escapes me. But
for sure. I think that, totally depends on the industry that it's in. I mean, maybe if it's my personal data, what I did on the internet, I think maybe we can work around things, the right to be forgotten. But when it comes to work I did on a railway, I don't know if that right to be forgotten comes into play as much, because, that should probably be tracked.
Yeah. I think, you draw a good distinction between two kind of quite different situations. And I think one of the solutions to this is actually that blockchain does enable you to own your own data and data record, which means that you actually then become responsible for implementing your right to be forgotten, which is in part making sure if you put records on the blockchain that you make sure that they're encrypted in a way that you can permanently revoke access. So I want to move down to the payments use case now, and in particular micropayments, because it was one of the things that Satoshi talked about in the very sort of early days of Bitcoin. So micropayments and frictionless micropayments, this is one of the sort of key potential features of Bitcoin, and several other blockchains have attacked this problem. and by frictionless, we mean low fees, low barriers, whether it be cross-border or whatever. And how can that change the game for business? I think we think a lot about cross-border payments and remittance and stuff like that, but business, how can they take advantage of this?
Yeah, so I think that what he had David said a little bit earlier about, the micro payments that occur that you guys talked about briefly. I do think that is a very cool and interesting application that could, change like the incentivization world in the next, decade or so, because right now it's not really feasible to create micropayments of a couple cents through the current payment platforms. It just goes through too many third parties, the banking, that it's just not really conceivable for a couple cents. But you have Upping, I think you had just mentioned. You have, the Brave browser. You have all these different platforms coming out that pay you such little amounts for the data and your actions that you do, but obviously over time this can incentivize certain behavior and add up. So I do think it allows for incentivization of actions that maybe were too small to incentivize before, and give power to users to share their data versus Google to share the data for you and collect all that money. It allows me to add up what I do.
So filling in, I guess, kind of what I started talking about a little bit earlier that excites me so much about what we can do with micropayments is in the concept of like a game modding world where other developers can just go on and extend different games that are out there. Well, they can build into that maybe a 100th of a cent or a 10th of a cent or something payment actually built into the interactions that they do. So there ends up being kind of these new business opportunities for game developers in our world where they can actually build up new features and their monetization for that is actually just built into using that feature. So if developers decide to put in these little mods or if someone decides to build out kind of a more expansive game world, the developers of those different mods and those different pieces can actually have their business model built right into the value that they're offering and to the logic that they're offering. And so there ends up being this kind of free market for all these tools that can be put out there. And we can have it so that, okay, if you attack with this sword that this other mod put into the system, they get a 1/10 of a cent just every time you use it. And that's just a tiny, tiny amount that you're not really going to feel. It's part of the whole gaming world. But at the same time, we have that ability that just as it's being used, the revenue is automatically captured for it, which is a pretty interesting opportunity.
There's a world of possibilities that have just never been possible before. And I mean, when you have a floor price of a 20 or a 30 cent transaction is probably the minimum viable. It takes a world of possibilities off the table. So I'm fascinated to see what people invent as a result of it being back on the table. So we're talking about the revenue side here, but of course, when you're trying to run any kind of a successful business, you've got to think about the cost side as well. What do you think that Bitcoin can do to make it cheaper to run a business? I'll start with you, David.
I think at where we're at right now, there's starting to be good development tools that are coming out, but I think right now there still is a pretty high cost of entry just for development teams to get their head around how do I use these tools. I mean, Bitcoin in specific it's a very much a blank slate where you have some really rudimentary tools that give you lots of, they give you lots of different properties that you can take advantage of, but we're not yet at a point where we have any sort of best practices or even really that established practices for how you go about developing things. So I think from a business standpoint, there is still some significant investment that needs to be done in either building the tooling that you need, which obviously is a significant investment, or just getting up to speed, getting your team educated in the different tooling to use. So from that standpoint, I think just getting started, there is probably still some areas that there can be some significant improvements. But other than that, I think just getting adoption, getting people to be familiar and comfortable with what's going on. Like as these different solutions start being built and permeated, I think that as long as we're all still moving forward and developing, I think time is just what it's going to take.
Yeah. Well, I'm going to add a little twist to the question for you, because I think in the consulting space, you probably have visibility of a wide range of business models and ideas. And I'm going to shift the emphasis to efficiencies. What ways have you seen that blockchain can add efficiency to existing business models?
Definitely. One of a really great application is like the international aspect of the blockchain. It's really hard for international companies right now to do transactions or different types of contracts or trades because they don't have an overarching governmental body. It requires quite a bit of trust to ensure that if the contract needs to be enforced, the contract will go through because there's not an overarching enforcement body. But smart contracts and the trustless blockchain system allows for these companies for the first time to maybe enforce their contract via smart contract, transact freely, and work in a more trustless environment. So that's one of the, I think smart contracts in general, like internationally, and then when you do bring it internally, I still think there's some things that still need to be built out, but the idea that once smart contracts are, a main form, you can take out so many middlemen, lawyers, different data keepers, all these different roles that now a smart contract can do automatically, that will improve efficiency so much and remove a lot of middlemen from the process.
Certainly. I think one of the big areas is probably going to be compliance, because automated execution of rules, etc. It doesn't necessarily mean that you can completely remove the human element, because there's still a requirement for audit, etc. But if you can automate so much of that stuff, because the cost of compliance is a huge cost for business these days. Supply chain is another one that I think is going to be huge. I'd like to get some thoughts on stablecoin tokens. It's a pretty kind of hot topic. I don't think it really became a topic until maybe 2015, 2016. But it's generally the idea of fiat as a Bitcoin, as a blockchain token. And some people view this as potentially threatening and competitive to native tokens, but others feel like it's a pathway to mass adoption. I'll start with you. What are your thoughts on this?
I think it is absolutely a path to mass adoption. There's so many things, as we've discussed, that blockchain can bring to business, but I don't think they're going to get into that business if you have such a volatile token, such as, Bitcoin or Ethereum as the, backbone of how all these things work. You're not going to have your main enterprise companies signing a deal for a couple million in Ethereum, and then a month later, it's like half the price. So for mass adoption, I think it is completely necessary. So, there has definitely been a couple different ways that, DAI versus Tether, how it's been implemented, and there's definitely better implementations. So I think it is, I think it's necessary, and it's just about creating one that doesn't just mirror our current financial situation, the dollar.
David, are you planning on using any kind of stable coin as part of your offering?
So we're definitely keeping an eye out on different things that are developing, but we're also, for all intents and purposes, essentially we have a stable coin of our own inside the platform, and it's not intended to convey any value outside of the platform, but what it really is when people deposit money with us, we tokenize that money, and it represents the money that is in their account, but at the same time, it essentially becomes our accounting system. So just as the tokens transfer throughout our platform. And when a player pays a fee or wins a reward or whatever, all those things, all those transactions are recorded, again, with that full graph of everything that it actually tied into. And so really that becomes the whole accounting system of, there isn't any worrying about debits and credits to accounts and whatever. It really is, you give us money and we give you this token, and then that token is yours and you hold on to it. And where you spend it and where you, like, when you're done playing or when you want to cash out, you literally just send those tokens to our cashier, and you get, I mean, it's very much like a poker chips at a casino kind of situation. But at the same time, those tokens directly represent the dollars that you have put in. So for our system, like, we are actively looking at other ways we can use established stable coins outside of our platform, simply because it would be awesome if we didn't have to take that upfront, the know your customer, full validation of who they are. It would be great if people could just bring money in as if it were cash. But at this point, that part is a big hurdle to our customers. And so we're actually kind of building our own stable coin. But again, it's like, it's almost more of an accounting token than it is a stable coin, but it's the same exact feature of, there is fiat that is backing these tokens one-to-one, and the token becomes kind of the how we track who owns it and who's owed what.
Yeah.
And I wanted to add on to that. Also, what we were saying earlier about user interface is going to be a big key for mass adoption. So it is very important that, you know, your 99.9% can interact with these interfaces, and they don't necessarily need to know that blockchain is even involved. So for them, they're going to see that their wallet or something has $7, and that should probably be saved in a stable coin, because you don't want them next time to go on and they have 3. Like, there's going to be no explanation to them for that. So yeah, I just wanted to add on that about stable coin and usability.
I actually had a staff member who was employed in a very, very non-technical role, started at Enchain, and I tweeted out her hand cash address, because it was a bit of a Bitcoin SB tradition at the time that new users, people would send them a bunch of tips. She actually ended up getting quite a bit of money out of this. And then the next day came to me and said, my balance has gone down. Are people taking their Bitcoins back? Or are people stealing from my wallet? And it turned out it was just it's a wallet that just happened to display your Bitcoin balance in your local currency by looking at an exchange rate. So it's a classic example of that. Fortunately, you know, she was around 50 or 60 people that could explain what was going on to her. So, if that was my mother, and she's on the other side of the world, so she wouldn't have been able to ring me at the time, I can imagine what she would have thought. Yeah. So I'm going to start this one with David, because your business is more obviously in the creative space, and this is not really about blockchain per se. It's more about building a business. And then what is the role of creativity in designing and building a business?
Well, I mean, I guess that's an interesting question. If you're not finding problems to solve and solving them, which obviously takes creativity, like, what are you, I mean, either you're just cloning someone else that's already out there and trying to offer a competitive service, or in most cases, like, what brings you value as a company is the fact that you're coming up with innovative solutions or new business models or new marketing, like new ways of tackling the businesses, the problems that you're trying to solve. And in order for your customers to find value in you, obviously you have to be doing something better than the other competitors that are out there. And so creativity, when it comes to really thinking up new ways to solve the different problems that you're offering solutions for to people. Yeah.
Paula, any thoughts?
It was just creativity when creating business. That was the question?
Yeah, it's kind of an abstract question, so I'll let you skip this one if you want to.
I mean, I agree with what he said, and then it's just the problems that come up every day. You got to get creative.
Okay, I'm going to start with this one again with David, because I suspect in your consulting business, you probably deal with people who are already on board in terms of blockchain adoption, I suppose. But David, this is the problem that you specifically have to solve, which is how do you turn blockchain skeptics into champions, or not necessarily even champions, but get them over the line of why should I use this blockchain thing?
Yeah, and for we kind of have two different client bases, and one is the players themselves, and for them, ideally, we don't have to get them over that hump because they don't even know about it or see about it. But for developers building solutions on our platform, yeah, I mean, that becomes a big hurdle in that we really need to make a case of why this is a better business model, why this is better than just building on Google Stadia or something like that for your game development. And I think in that, really getting, preaching the picture of, at least in competitive gaming, which is kind of our focus, of how being able to audit and being able to have regulators audit and your community audit everything that's happened to ensure that we are playing by the rules, to ensure that we are being fair in what we're doing. I mean, everything that we do, every random number that gets introduced, every timestamp that we put on something, we are signing with our Bitcoin keys that says, this is, I am attesting, I am legally accountable to what I am saying with this data that I'm putting out there. And so as far as a consumer trust and also there's a lot of really other cool things you can do with it. But that's one big thing. It's just that the consumers can trust you, the communities can trust you, the regulators can trust you and can audit you. That's a big piece there. Additionally, I lost my additionally. I guess I'll leave it at that right now.
Do you have an additionally, Paula?
Yeah, I guess how you get people in. Yeah, I definitely agree that there's definitely a large portion of the population that you probably like don't have to get in. They're gonna like continue their lives and absorb whatever tech comes their way. But you know, the people that are interested, I think it's definitely going about it with different angles. You know, the finance people, there's obviously, you know, potential gain there. So you get them just to invest. But, you know, you can definitely sector based on what each person is, whether it be the supply chain. Like my mom, she works in pharmaceuticals, and I've been working in this for 3 years, and she has not been able to like comprehend what's going on until I finally talked about like the supply chain and like the pharmaceutical chain for that. And it was like a light bulb went off in her head, and she suddenly could see such an application for blockchain in general. And now she keeps sending me articles randomly on different blockchain applications. But, you know, there is, you know, the smart contracts, or, you know, when I go talk to people in the entertainment industry, I talk about the intellectual property, how maybe it won't be pirated in the future if you had like your movie on the blockchain versus on the regular internet. There's just, there's so many different applications that disperse out that I kind of cater it to that person and why they might be interested.
Actually, it isn't my additionally, but I've got a different additionally. So taking this idea that says, building up the idea that there can be a trust and that this data hasn't been changed, and also auditability, and just adding in the idea of simply attestation that says, when I post something, I'm actually signing that with my keys. Allows us to move to a world where things, I mean, our world of you can't trust anything you see, you can't trust anything you hear online, any of that, we start getting the tools to be able to build actual engines around just filtering and trusting data. And so that, I mean, whether it be a social media where someone makes a post that references data that the CDC released, and then other people, I mean, people can start building filtering engines on that starts putting value on different sources of data. And you start getting a lot more information such that you can start gleaning out what really are the things that you care about or that you trust in a way that's very different than relying on Twitter's algorithms or Google's algorithms or Facebook's, but really there can start being people who release clients for your phone that will watch this social blockchain and be able to balance how to weight things, how to value things. And that itself there can be lots of different solutions for that. And there can be competing filtering engines. And just having that attestation that says this piece of information is tied to something that can be tied back to a real person or a real organization, and even tying together that this person is a member of this entity or was a member of this entity during the time that this got posted, but then they started posting other stuff after they left that is antithetical to that. Like, you start just getting so much more information in just how things are connected and who people are, that we can really get to a point where the whole idea of who we trust changes completely. And it might still be the algorithm, but it's not their algorithm, it's my algorithm. It's the one that I have chosen to build up, or that I trust this other organization to build up, or there's just a lot more choice at a far more fine-grained level.
Certainly. I deal primarily at the enterprise level of things, talking to very, very large businesses and sometimes government departments. And if I had one take-home message for anyone trying to sell blockchain, is don't mention blockchain. Tell them about the benefits of blockchain and how they can actually, help them do their business. Just bearing in mind that we've got probably quite a lot of developers in the audience who are interested in blockchain, and some of them may well even be new to it. Some may have ideas of their own. Firstly, I'll point out to them, please remember that you can ask questions, and I will put them to the panelists. Stathis, you have asked me a question, and I'm afraid I don't understand what it means. He says, Steve, I think you mentioned a service for websites and their runtime. Could I repeat that, please? So if you want to maybe clarify that, I'll try and get that question answered. But for those developers in the room that might have the next big idea, I think you've probably both been through this yourselves. You've got the big idea. What do you do with it? What's the next step to turn that into something real? Paula?
Well, I mean, my first step when I thought of my big idea was Google how to start a business. But then, I mean, is this just a generic, like, how to start an idea?
I think so. Yeah. You've been there before, so.
Yeah, I mean, I definitely I resonated with what he said. Like, starting a business is creative. It is a lot of problem solving. So for me, it was, step one, create it, or start the company. Step B, figure out, what we need, what are the basic things that we need to get to a sustainable level, and what can we do different than our competitors? What can we do better? And it's a lot of trial by error, but that's okay. Everybody's kind of faking it till they make it. So yeah, for me, it was just like, not so much like, don't be afraid to fail. And Google's there to like answer any question that you may have on your journey. So I don't have a very concrete answer, because I think everybody's journey is going to be a little bit different. But I think it's just being ready to like figure out any problem that comes up.
I'm old enough to remember when there wasn't a Google.
Yeah, I don't know what I do.
I had to go to the old library and flick through card catalogs. But, we have Google now, and in 10, 20 years, we might even have a Bitcoin or blockchain Google. David, you've been through this process yourself. What was the seed of Chronoverse, and how it kind of evolved from there?
Yeah, actually, I mean, I don't know that I'm going to say that this story is necessarily the way that everyone should be doing it, but Chronoverse as a business idea isn't where we started. We started very much with crypto fights as a very rudimentary idea of a game on the blockchain. And my personal route to that was basically, I got super obsessed with blockchain, cryptocurrency, all this stuff, to the point where, and my old company, I had started like 9 years before, and I was just running out of steam on it. And so I just kind of jumped in head first, and I had a small exit from my old company that was able to pay me to live for a couple years while I started playing around. But at the same time, that was the only money I had for long-term savings. So there was kind of a like, this has to turn into something or I need to shift gears. And so I just jumped head first and started building, started researching, starting to figure out what we could do as a product. And with us, like Crypto Fights this is something Adam, our CEO, was already starting to think about, and he was looking for resources to kind of help him. And so I jumped into that, and then we spent a couple months on it as an employee. And then I'm like, no, this is something. Let's just build this toward an investment toward what we're going to start and make a company out of it. So it was a really fulfilling yet very stressful process, because essentially every month that we're not making money or we don't have some sort of funding is a month less of money I have to retire on or to. So, I mean, there's definitely a lot of risk of just jumping and go with it. But if you have a passion for what you're doing, which is, at least for me, that's been a huge motivation of, I mean, this is what I'm thinking about when I'm not at work. And so this might as well just be my work and it's pretty much turned into, for the most part, my life I mean, my best friends are all people that I know in the Bitcoin community and that I see once a year at a conference somewhere, but we talk online or we talk through kind of new potential ways that we can handle distributed state caching and just all sorts of cool, nerdy endeavors.
And I'd echo one sentiment, and I hate to sound like a motivational speaker, but really don't be afraid of failure. Every failure is actually a lesson learned that brings you one step closer to the ultimate success. So we're approaching the end of our time slot, so I've only got time for a couple more questions. One serious one, and then one warm and fuzzy. Actually, we have an audience question, which is very similar to the question I was about to ask, which was how do you try to get into regulated industries with blockchain? And I'll give you the choice. My own question was more of an ideological one, which is, well, maybe a pragmatic one, actually. Should you regulate blockchain? Paula?
You know, I think it would be a mildly unpopular opinion in certain circles of blockchain. But I do think there like some form of regulation is probably necessary just to, you know, protect against certain, you know, I could talk about some really like unfortunate behaviors that could occur on the blockchain. I don't know if I want to talk about them, but I do think there needs to be some general guideline and, you know, I mean, I guess, yeah, not putting out like hits on people, like on the voting, like, yeah, like that shouldn't be allowed. That should be regulated. I don't want a world where that is the case. But yeah, I mean, it is a really hard industry to regulate because, you know, it is so fast moving, it's everywhere, it's still a little hard to understand. But I forget what the audience question is. I'm sorry. What was it exactly again?
How would you try to get into heavily regulated industries with blockchain? So I imagine things like
very carefully, like you know, with probably a decent amount of legal fees. Like yeah, you definitely need some form of compliance and legal check if you want to get into the more you know, specific areas, gray areas.
I think I take a pragmatic approach in that it's inevitable. People thought that the internet was going to be the Wild West once upon a time, but and it took 10, 20 years, but eventually the government managed to figure out how to regulate it. And whether that's a good or a bad thing is an open question for debate, I suppose. But it does mean that some of the more nefarious activities are not necessarily gone, but they're harder to sort of, you know, carry anonymously. And people that have children that are worried about being on the internet, I suppose that makes them feel better. People who you know, want ultimate perfect freedom, that makes them feel worse. But Yeah, my pragmatic approach is it's there, whether you like it or not, it's probably going to happen.
Yeah.
Which is similar to my approach to patents. They exist, so it doesn't actually matter whether I like them or hate them. I'm subject to the environment that's created by a world that has a patent system. David, do you have any thoughts on?
I mean, pretty much. I was going to earn some Steve Shatter's cookies because I was basically going to say the exact same thing. As should it be regulated? I don't know. Probably some areas yes. Probably many areas no. I tend to be a less regulation, but does that mean it won't be? No, it's going to be, and largely a lot of the regulations that are out there actually are technology agnostic. It doesn't matter if it's a blockchain or if it's whatever. These are regulations that already exist. I mean, if we're going to do skill-based gaming in our world and that's legal in 42 US states, well, we need to make sure that we're not doing skill-based gaming for money in those other 8 states, because if we do, we're out of compliance with the law. It doesn't matter that we're running on a blockchain or not. The definition of our business is regulated, or there is regulation around it that we have to comply with, or else we're liable.
Yeah, this is the pragmatic approach that I actually see in any serious business that's looking at doing something with blockchain, and I actually don't need to hold a personal opinion about it to make a decision about how I'm going to approach it, because if I want to do business with people in the financial space or in the gaming space or in the the healthcare space, for example, providing them solutions that make compliance feasible for them is not actually even an option. So yeah, all right. Well, I think we'll close, like I said, with a bit more of a warm and fuzzy question. And I guess this is the pick your ideology question, if you want to lay the cards on the table. But what are some of the biggest social challenges that you think that blockchain is best suited to address? We talked a lot about business, but I'm a big fan of saying that the incentive model of Bitcoin is fundamentally built on the idea that it incentivizes honest behavior. It makes honest behavior the path of least resistance, and it makes it easier for people to be better to each other, simply because they'll be rewarded for doing so. It doesn't require altruism. It doesn't require nobility of purpose. It's just what actually gets you the best outcome. And I don't know if that's an indictment on humanity that we need a system like that, or that someone invented a system like that because they thought that was a way to make the world a better place. But it's there, and I think that's a noble purpose. So I think anyone who's around blockchain for long enough has probably thought about how it's going to change the world and what the world might look like in 20 years' time as a result of Bitcoin adoption. So I see Paula nodding there, so I'm going to pick on you first for an answer.
Sure. Yeah, I think it's one of the things that I found most exciting when I first got into the blockchain space is just how much it, especially back when I got in, how much it really didn't care where you were from. Everybody can interact with the blockchain for the most part on a same playing field. It allows people from the remotest parts of like Africa to invest in tokens. I mean, maybe they lose, but like they can play a part in the economic potential gain. Or there is like, I'm a bit of a globalist, so I really like that it does bring in international business, international from anywhere, investments. The open source technology can allow like smaller companies with less funds to kind of jump into an existing framework and build off of it. There's social good aspects. Like if you have a nonprofit who's putting their payments on the blockchain, you can verify that that nonprofit is donating as much money as they say they will to the fund that you want to promote versus, keeping 90% of it. So there's so many different applications, but I really think, and then there's the obvious, companies that maybe have failing governments, they can save their money in a stable coin, or escape a little bit from maybe what's going on locally for them. So I really would love to see a world where it doesn't get so regulated and so split up that changes. But I would love if it continues to be a place where everybody can interact quite freely.
Yeah,
But
I think
aside from everyone playing more games and being happy for the fact.
Yeah, I think, I mean, on top of just the social attestation aspects I mentioned earlier, where essentially you can build up trust or essentially there can be provable identity, not that I know that you are Steve Shatters and I know your address, but that I know that your entity that you have online has behaved in certain ways in its past. Or if you don't reveal that information, or if you don't tie your history to where you are now, well, then there's nothing that actually gives, essentially your weighting can go way down because I don't have any history on you. So we start to this point where we can start valuing people in a measurable way. But then I think the other big thing is, I mean, if you look at the move toward the gig economy in the last decade of the Uber and the Grubhubs and that world, that ability that says, I've got a car and I'm driving for these hours anyway, so I can just put myself to work. Those opportunities just explode when there is opportunities out there for you to just pick up. So one example is there's a system in the Bitcoin SV space called Tonic Pow. That's essentially it's a social marketing tool where companies will put ads out there, and you can, if you have a big social following, just grab those and share them. And as people click through to them, you get the portion that a Google gets right now for serving up ads. And you take that on then a much broader scale. You mentioned BitPing earlier. Like, there ends up being all these opportunities for people who can spend an hour here or there, or can spend a full-time job, whatever, of just like finding opportunities that are out there that will pay them in real time for what they're doing. And it really unlocks the kind of the ability for individuals to be small businesses and to kind of make their own way in life without necessarily clocking in 9 to 5 for someone else. It's just, okay, if you can search the internet for these opportunities and find what's out there, and you can do the service and you can get paid for it. I mean, on a whole global scale, that alone there has potential to raise third world countries and populations greatly in just how they can live their lives, because there's no gatekeepers for that kind of stuff. It really is, you find the opportunity, you deliver the service, and you're paid immediately. And the measurement of how good of a job you did isn't really based on what some manager thinks of it. It literally is, did you complete the terms of what's being asked of you? And if you did, the code just says, okay, you matched it, here's your money. There isn't the intermediaries to kind of gum up the works.
If there was one word that I could choose to summarize what I think that Bitcoin can do for the world, I think it is actually opportunity, and I think that's a good word to end on. So I'd like to thank Paula and David for sharing their thoughts with us today, and we'll be back in a few moments to delve back into the technical.
Your app just crashed. It was struck by a hammer manufactured in 2005 by Harry's Hammers. The hammer's head is composed of 75% nickel, 20% steel, and 5% iron. Curiously, a hurricane just came down in Iran.
Hi everyone.
Delving back into the world of technology and technical implementation with our next speaker, Nazar Hussain. Nazar has been in the software development industry for over 15 years. He's worked at Lisk and he's been a senior architect leading 3 products for eComb. But he's been working on blockchain development of late, which has become one of his passions, and he's going to help us figure out how to build a blockchain application in JavaScript. So thank you, Nazar.
Yeah, thanks for having me here. And hi everyone, it's Nazar here. And today we will be talking about Lisk and Lisk SDK and how can we build a blockchain application. My name is Nazar, as Steve told. I've been working with the Lisk for over 3 years now. And if you want to find out more about me, you can check on my LinkedIn profile. And so here is the today's agenda we have. So first thing we will talk about what is Lisk, and then we will talk some of the points that why Lisk is so important in this ecosystem of the blockchains and why we recommend you guys to use the Lisk. And then afterwards we will go through some of the timelines and see how can we relate the new features that we are going to release with the timeline. And then afterwards, the most important topic of the today session is the Lisk architecture that we designed, which is flexible, integratable, and open, that can help you build any blockchain application, whichever you want. And then at the end of the session, we will go through a hands-on demo where we will together build the blockchain application using simple JavaScript. And if you have any question, I will take those questions at the end of the session. I request everyone to be focused to the questions only related to the technology aspect of the blockchain, and more importantly, only focus to the content of today's session. And if you have any extra question, we can take them over to other channels afterwards. And let's start with today. And here we have our first topic that we introduce you to the Lisk SDK. And Lisk motto is that Lisk has set itself as a blockchain technology accessible to make the blockchain technology accessible to everyone. That's our goal, and that's what we are working for the last 3 years. And we have seen different blockchain aspects, and yeah, it's a complicated technology, and we decided that we need to build it in a way that it becomes accessible for everyone, so anyone can use in the future. And if you ask a question, many of you have heard about us, about the Lisk. These are the 4 points that can cover the whole ecosystem that we are building so far. We have a decentralized network that is running over 3 years now successfully, and we are building a blockchain SDK that is purely in the JavaScript that can help you to build any kind of a blockchain. And then we can, the Lisk is itself a blockchain application platform where you can build multiple blockchain applications all together, and you can also link them together, that we will cover afterwards. And then Lisk itself is a token LSK, and this LSK token is been live and have a very huge value on the token market. You can check it online with other details. And on with that, I can share with you some overview what the Lisk itself is. We are in the blockchain industry since 3 years. We are technically a delegated proof of stake consensus algorithm. So don't mix up with the proof of work. And we are a team of 30+ employees working as a light curve team and building for the Lisk. And we are the first on CryptoMesto for GitHub activities for the last 6 months. And we have different community center in Utrecht, Tokyo, and Berlin. And you should not forget that we have an opening event for the Lisk Center Berlin on 20th of November 2020, and it will be an online event. I request everyone to join us there, and we will share more details of the LISC Center and the activities we are going to perform there. Our mainnet is optional, operational since 2016, and so far we don't have any kind of attack or any problems running that mainnet. And now we go to the major point, that why you guys gather here and why you guys should be interested in using the LISC. So first of all, LISC is a research-driven product. It is not something you can say technically adventure. It is based on some research. We have a proven research. We have a team of 5 full-time scientists which are working on providing the base research, on top of which we are building this technical solution. So anything you will see, any feature you will see in the LISC, you can relate or find out the particular research pattern or research papers that we have published against it, which we call them LIPs. And then the LISC is itself a developer-focused product. It is not built for some kind of a technical corporate sector. It is built totally focusing the developers' need and totally focusing the developers. And it's accessible because it's been totally built in the JavaScript, and JavaScript is the most accessible technology around here, and it's been known to everyone. So anyone who knows a simple JavaScript can build a blockchain application using the LISC SDK. And LISC is a flexible, provide you the flexible architecture, which we will explore later, which can help you to build different use cases because of the flexibility it provides. And then we are a scalable solution. You can build side chains with us, and that side chains can grow independently, and they don't have any kind of problem related to the exponential growth or dependency on the mainnet. And with that said, is our timeline. We were started in our inception. Our idea was started in 2016. We launched our testnet, and we had our ICO in 2016 as well. And with that said, we launched our first alpha SDK, which was version 2.1.0. It was in July 2019. And after July 2019, we had been working very hard on a lot of other stuff. And some of those features I can highlight you guys. And if you have any questions related to those features, you can post me afterwards in the session. So LISC 2.0 was an alpha SDK, and afterwards we have the LISC 3.0, and these are the highlights for it. We introduced a Byzantine fault tolerant consensus protocol in LISC 3.0. We also introduced a pair selection and banning mechanism, and we also have covered the problem or attack which was possible to replay the transaction in a different chains. So we have fixed these things, and like to be highlighted, these are just the highlights. These are not all feature set that was introduced in 3.0. And afterwards, we have the LISC SDK 4.0 highlights. We introduced a lot of new features. The most important one is that we introduced the dynamic fee system. We introduced the byte-based block size. Initially, up till LISC 3.0, we were running the node with number of transactions per block. But with LISC SDK 4.0, you can define the block size in the term of bytes, and then the whole chain will grow accordingly. And we introduced a new multi-signature architecture, and we also remove the timestamp and introduce the nonce that can help you to avoid the double spending attack. And we also introduced the vote locking period so that people can put their stake into the network, and then they should contribute productively and make the network more secure. And with that 4.0, we introduced a new feature which was like a long awaited. We introduced the standby delegates. So not only the delegates which are forging in the network, now the delegates which are not forging and they are just contributing to the network, they will also be incentivized with this LISC 4.0. And in Lisk 5.0, we have more features. We introduced the transaction ID system, new block ID system. We also introduced a generic serialization method, which can help us to convert the data into binary format back and forth without any problem. And then we introduced the numerical trees to include the proofs. And then there is a lot of different Genesis block and snapshot and hard fork processes introduced. And most importantly, for a developer perspective, we have introduced embedded databases in Lisk SDK 5.0. And before that, we were using PostgreSQL, and we observed that some of the community members were not been happily using Postgres. They were having a trouble in setting up. So we remove the Postgres dependency, and we can completely go to the embedded databases. And we also remove the dependency of the undo step that you had to define for your state transition. Now you don't. We will calculate the state transition automatically, and if required, we can do undo automatically. And in this version, SDK 5.0, we introduced an on-chain architecture. And this on-chain architecture is the one which gives you the most flexibility to create any kind of a use cases or develop any kind of a use cases on Lisk SDK 5.0. And with all these features that I just highlighted to you guys, these total are around 850 issues, 790 pull requests, and 30 plus libs that we have covered. And all these things we have covered in the 1 year time frame. It's a pretty short time frame to cover all these things, but we have made it possible even during the epidemic. And that's all for theoretical stuff and explanations. Let's go more deep towards the technical foundation of the Lisk SDK, which is our Lisk SDK architecture. I can easily and more abruptly can divide or can specify 3 traits which we focused in our mind to build these architectures. And the Lisk architecture itself have like a basis on these 3 action points, which are the flexible, integratable, and open. And for each individual trait, we focus particularly on that trait, and we develop a particular architecture for that. So for a flexibility perspective, Lisk on-chain architecture gives you all the flexibility that you need to build any use case in the blockchain. And then blockchain is a bit complex stuff. You need to integrate the blockchain into some other system. That's a pretty much everyday use case. So for that particular aspect, we have introduced the Lisk off-chain architecture, and that can help you to build the integrations for the external tools that are connecting to the blockchain. And then we have another aspect which was that some people may have different technologies or different tools that they are using. So we developed the Lisk communication architecture, which is open. It does not have a dependency of the JavaScript. If you are a PHP developer or if you are a Python developer, you can still use the Lisk communication architecture to communicate with the blockchain application openly. So these are the 3 traits, and now I can dive deep into the Lisk on-chain architecture, which is quite interesting. So remember that this Lisk on-chain architecture is the one which will give you all the flexibility you need to build any of the use cases. And in a Lisk on-chain architecture, the main aspect or the thing that you are going to design is the Lisk module. So everything you design is called a Lisk module in the on-chain architecture. The Lisk module will bound it to the application that you are building. And Lisk module has 3 major points. One is the data structure, one is the control, and one is the interfaces. So it gives you the flexibility of defining the data structure that you want to use, whether it is the account schema or whether it is a transaction asset schema. You have the full flexibility of defining any kind of a data structure. These data structures are isolated, they are unique, they are readable. So if you define any account schema, that account state or schema will be isolated to any other module, and that will automatically be serializable to the binary format, and this binary serialization is be done with the help of JSON schema and protobuf. So we have developed our own encoding scheme, which is based on protobuf, but the interface that it defines is based on the JSON schema. So anyone is aware of JSON schema, which most of you guys should be. So you can use the JSON schema and then serialize data back and forth to the binary and JSON format. And then we have the control over it. Then once you have the data structure defined, then you want to control it. Then we provide the lifecycle hooks of the blockchain application, whether it is a block, whether it is a transaction or something else. You have a full control of all these things. These controls are all granular. You can go up to the transaction, individual transaction level, or you can say up to a higher level on the Genesis block or the block. These are isolated, these are fail safe. You don't need to worry about anything. If something goes wrong, it will be reverted automatically. And then we have, you need to define the interface. So once you define a module, that module may or may not want to interact with other modules or complete some kind of a business requirement, then in that case, you have to define the interfaces. And there are three types of the interfaces that you can define. One is the reducers, actions, and events. And I can go into more details to those in the hands-on demo. And these are the list of default modules that we can publish within the SDK. One is the token module, which is responsible of handling all the balance related transactions, whether it's a transfer transaction, so it's handled by the token module. Then we have a sequence module, which is handling the account nonce, which can help you to protect the double spending attack. Then is the keys module, which is responsible for verifying the signature of the transactions or verifying the multi-signature accounts. Everything has been handled by key module. And when we have the DPoS module, which is had a core responsibility of managing the consensus related to the DPoS. These are the four default modules that comes along the SDK. You don't need to install them. They will be pretty much configured and available to you. And then we have this off-chain architecture, which I earlier talked that this is integratable. So sometimes you need to process something which is not related to the blockchain, which is not related to the transaction, which is not related to the block, but it is still some kind of a processing, which we tend to call an off-chain processing. So this for particular off-chain processing, you can use our Lisk off-chain architecture. You can create a plugin. You can put any kind of an independent logic into that plugin, and that plugin can interact with the application and provide actions and events which can be used elsewhere. So this way, the application will stay isolated, and your application, your plugin can still run an independent business logic. And there is a flexibility that if you want to run that particular plugin in the same process, or you want to run this plugin in a child process to use the maximum performance of the hardware, so it's up to you. That is also possible. But to remember that this is an off-chain structure. You don't need to process any blockchain related data or any blockchain related processing in the Lisk plugins. So for blockchain, you go to the on-chain architecture and define the modules. So once you have the plugins, then we have this these two plugins that we expose from our SDK. One is the HTTP API plugin, and then we have this Forger plugin. These two are very pretty basic plugins that are available, but they can provide you all the features that you need to cover up the requirement of any simple blockchain use case. And then we have this open Lisk communication architecture, which is based on the IPC Unix sockets. Whatever blockchain application you build, it will expose an IPC Unix socket where any JavaScript or any tool in the Rust or any Python or any other language can interact with the IPC socket. and they can call the actions, or they can listen to the events within the application, and then they can do any kind of off-chain processing according to it. And with that said, this is all pretty much, and with these three particular things, Lisk on-chain architecture, Lisk off-chain architecture, and Lisk communication architecture, you can build any kind of a use case that you want without any problem. And for a bird eye view, I will say that this is the whole application that you will be building or you will be looking into. Lisk application is composed of these layers. One is the node layer, one is the modules layer, and then the plugins. Node layers consist of forging logic, network logic, block processing logic, and synchronizer. And then for the token modules, we have tokens, sequence, keys, and depots. And there is a space for you to create your own modules afterwards, and you can plug them in. And for the plugins, you can create, we provide HTTP API plugin and the Forger plugin, and same as you can create your own plugins and plug into the application. But the whole layer will be called an application. And afterwards, we have this Lisk communication architecture where you can connect external tools like we have Lisk Commander or we have Lisk Core CLI, and you can build your own tool in any other language or any other platform, and you can link them with your application using the Lisk communication architecture. So this was all of the bird eye view on technical aspect of the Lisk architecture. And with that said, I was talking a lot about the use cases that you can build. And yes, there are pretty much a lot of use cases that you can build. So let me highlight some of those. So this is a research paper from Credit Suisse Research, and they categorize the different use cases of a blockchain into three major categories. One is the disintermediation of the trust, one is the immutability, and then is the smart contract. And within these categories, you can see different sectors which can cover up here. And I would say that based on the Lisk SDK, you can pretty much do anything possible in these green and the blue circles. Either is the disintermediation of the trust, either it is an immutability. You can do anything related to health records, art registered, crowdfunding, fintech, whatever use case you want to build, you can do it easily. Related to the smart contracts, Lisk SDK does not provide any built-in or ready-to-use feature for creating smart contracts, but there is possibility that you can still create a platform using the Lisk SDK that can provide the smart contracts, but that topic is not part of today's session. So you can pretty much focus right now on any of the above these of the use cases that you want to build, and with these use cases, we can also build a hand-on demo. I prepared something for you that I can show you how easy it is to build a blockchain application using Lisk. And one is we will be preparing a non-fungible token for it. A non-fungible token, if anyone of you don't know, so non-fungible token is a digital token which is unique, which is immutably interchangeable, and which is indivisible. So you guys can explore more details of NFT further, but I can summarize you that unique is mean that it is something unique which owned by someone which cannot be existing elsewhere, and it is not mutually interchangeable for like a normal token which is interchangeable. For example, you have one Bitcoin, you give it to someone and you get one Bitcoin from someone else. So it doesn't matter to you. It's the same thing that you have one Bitcoin. But for an NFT, it is not mutually interchangeable. Something you have is the unique and it cannot be replaced by some other token. And same as you have the NFT tokens are indivisible. They can be they cannot be divided into the chunks or been segregated into different parts. Like Bitcoin, you have one Bitcoin, you transfer one half Bitcoin to someone else. This is not possible in an NFT token. they are not and never been indivisible. So there are different use cases that you can build using an NFT token. One is the crypto collectibles, which is the most famous one, and which is available. And one which is people are crazy about is like crypto kitties. And then a digital artwork can be implemented in an NFT token. Event system or a non-fungible event can be, whether it is an event to a concert, whether it is an event to an airline, like ticket to the airline. So anything you can build with a ticket system with the NFT. And an NFT can be built to create an item in the universe. A virtual universe can be a game or any other thing, any fantasy. So you can represent any NFT token associated to any item in a virtual machine. And NFT also can be used as an identity, because identity has all those features that it is unique and it is indivisible, non-transferable. So you can use NFT token to build a digital identity solution as well. And the good thing is that we will be building an NFT token today, which will be pretty much all that you need. And then you can add more details related to a particular use case in that NFT token, and it's a ready to go solution. So what is our non-fungible token? And so our non-fungible token will be a blockchain application which will have a support of an NFT token, and that NFT token should have an initial value, and it should be purchasable with specifying an auto purchase margin. So if you specify a purchase margin, that let's say my token has an initial value of 100 and it has a purchase margin of 20, that means anyone can purchase the token automatically more than 120 token value. And then it should have, the NFT token should have only one owner at a time. So it cannot be divided among two people. And if you set the purchase margins to 0, then they will become non-purchasable. And if you have a money, you can create any non-fungible token. And if you have a token, then you can transfer it to your own token to anyone without specifying or fulfilling the profit margin requirement. And anyone can change the purchase the NFT token. And last part of this use case is that those NFT tokens should not just be inside the blockchain, and they must also be accessible from the outside of the blockchain, so we can build any other tool or use those tokens in a different use cases. So this is pretty much all of our use case that we want to build. And if I segregate these concepts into different categories or terms that we use commonly in a blockchain, and particularly in the Lisk SDK ecosystem. So this is pretty much all. The whole thing that we want to build is a Lisk is a blockchain application. And in the blockchain application, this NFT token is a particular behavior of the blockchain that we want to build. So this is a module. And this last part is the one which is say accessible. So so you can see that it's a non-fungible token should be accessible to the outside. So this accessibility feature is something which is not been intended for the blockchain itself. So we will build it as a plugin. It will work with our application, but it will not have any kind of a dependency on the blockchain itself. And then within the module, if I say that token has an initial value, token has a purchase margin, and token have an owner, these are all of the account states or the token states that we want to save inside the blockchain. And then in the yellow section, we have different kind of behaviors that we want on top of the NFT token. One is that someone can purchase it, someone can transfer it, someone can make it non-purchasable. So these all are the behaviors, and in the behavior term, we call them the transaction. So apparently, if I look on this diagram, so first thing we need to build is an application, and within an application, we need to build a module and a plugin. And then within a module, I can see there is some account schema that we need to define, or the state schema that we need to define. And then we have these transactions, 1, 2, and 3. 3 transactions that we need to define to fulfill these 3 behaviors, and then we will have a functional blockchain. So with that said, now it's the time for doing it practically, and let's do it. So all in one, you need just one package to build this, which is the Lisk SDK package. You can install it, the latest version of the SDK from our own registry. Since I'm doing this demo with the latest SDK 5.0, so you have to use it from our own registry. It's not yet published to the NPM, public NPM, but we will be publishing it to public NPM soon. But it's open public, and you can use our registry without any problem. So you just need to install the Lisk SDK at latest. Say, I am in the demo, and let's say I start with it, and so I did all these things, and I have a pretty much simple package JSON file which have the Lisk SDK and which was installed using the tool that I just command I just shared. So let's create our first file and say index.js, and we want to build. Hope you guys are seeing it clearly. The code is being shared and visible to everyone. So we need to require a Lisk SDK package, and the most important thing that here we need to require is the application. And then we need to require something else, but I can go afterwards. So we need to build our first application. There are some things that you need to define. We have a pretty much a configured application available that is called the default application. So that can avoid you to create to define some application without the default modules. If you call using the default application, then you will get an application which will be pre-configured with the default modules. But if you don't want the default modules, then you can use the constructor to use it. So the default application need two things that are the Genesis block and the configuration. And for particular part, you can use the configuration from the package itself. You can use the Genesis block from the package itself, and then you can pass the Genesis block and the config here. So this is the pretty much anything that you have to do, but for the sake of the demo, I'm not using these configurations. So I am using my own configuration file that I have, and I'm using my own Genesis block, which I have. But if you want to explore, you can simply use the Genesis configuration that is being exposed using the package itself. So I'm going to use these configuration that I have, and then I pass the configuration, and then we have pretty much everything configured. Our application is ready to start. We just need to call it start, and this, let's put some message here so you can see if application is started or not. And in case of some error, you can also want to see the errors. So we have all, and if you guys can see, these are all just 1 or 2 lines of the code that without the package dependency, that you can simply start a blockchain application. And now if I want to start this blockchain application, I just need to start it and it will be working. So we have to clean this up something. I can figure this out later, and we can start. So I did clean up a bit of a cache that I had earlier, which was causing a problem. So with these simple lines of code, and I was able to start a blockchain application. You can see that it started forging, and the basic, the default block time is 10 seconds. So you will see that after every 10 seconds, a new block is being forged. Let's wait for another block. So we have block 4, and it's growing and it's growing. So this is pretty much all that any blockchain need, and it is been predefined and pre-configured with the with what we have already, the default modules. So you don't need anything else. Now we go towards the other part that I was referring, that we need to build a module. So we need to build a module, and that module can be called here, and like base, you need to include a base module class, and then you need to create a module here, and the module extends base module. So this is a module you will get. Then you have to specify an ID and name of the module, and this is the ID. Let's say we can say name is equal to NFT, and we can say ID equal to 1000. And why 1000? Because it's a custom module. First 999 are like restricted for within the default modules domain, so you can not use it. And then afterwards we just need to register a module with the particular application, and Hora, you have a running module that have an NFT, and it has been configured and it's been ready to use. But since I can now go to the further details of the code, and we can show you directly into the code, because we don't have so much time. So hope you guys can see the code clearly. So here was like we were at the time. So we have this NFT module, which have these base modules extended from the base module, and this is the account schema of the base module. And we are modifying the current account or the default account, and we are specifying that now account will have a new properties, which is an own NFTs properties. This property will be an array of the IDs of the NFT tokens that an account will own. Because account can have an NFT token can have only one owner at a time, so there will be a cross reference of the owner. So the token will know about the owner, and the owner will have a reference of the NFT token. So this is all that you need to define in a module. And if you focus here, we specify the transaction assets, that these are the transaction assets, because there were 3 transaction assets that we want to perform. One is the create NFT, one is the transfer NFT, and then is the purchase. And for that particular part, I can go into the transaction assets, and I can explain you guys with this NFT asset token. So create NFT is again a simple class which is extended from the base asset. Then you can name it, you can specify an ID for it, you can specify a schema for it. This is a base JSON schema which you use in the module as well. And here we define that to create a token, you need to have a minimum purchase margin, and you need to set an initial value. And if you specify these 2 attributes in a transaction, then we can create a token, NFT token for you. And here is the apply logic for it, that you will get an asset state store. State store represents the in-memory store for the current block which is under processing. And then you know the transaction which was being processed. And at the time we simply do some logic. We call from the account state about the account, and we get the minimum balance of the account. And here are some checks that we need to perform, that if the initial value is minimum, then the remaining balance. So user should not have user should have the enough balance in the account, so he can create an NFT token. And here we created an NFT token. I will explore this later. Once you have an NFT token with for the owner address for a given transaction nonce and for a given initial value, we set this token ID into the owners, and then we updated the account for this particular sender address. And we did not forget to debit the balance of that sender, because he just created a token, so his balance will be debited afterwards. And then we save those tokens into the state store as well. So same is for the purchase. If you want to purchase an NFT token, you need to specify an NFT ID, you need to specify a purchase value of it, and then afterwards you need to apply this transaction. And when you are processing a transaction, So you need to first check that the token ID that is being represented as an NFT ID is valid, and then you need to specify which purchase value you want to purchase. So if everything goes well, then this is the purchase value that say the minimum purchase value which was valid for this particular token. And if that is valid, then we simply remove that token from the token owner, and then we put that token into the owner like current purchaser's account, and we also change the value and the owner of the token itself, and we debited the account of the purchaser and we credit the account of the token owner. So this way one person has the given the tokens to the other one, and in the sale, in the purchase of the particular token. So this is all, and since we don't have enough time to go into further details, there is only one thing I can show you, and then I will go towards the UI side of it. So this is the logic for creating a token I used, and this is owner address, nonce, value, and minimum purchase volume. And we use the cryptographical hash to generate a unique ID. And since owner address is always unique and the nonce is always unique, so we use this as a seed to create the ID of the token that it will always be unique and identifiable. And then we use our codec that we are available in our SDK, and we use it to encode data into binary and saved it, and same for getting the tokens. So this is at all, and now I want to show you guys with the demo. Let's start our backend application. So NFT blockchain application I want to start. So it started, it's running, and I have built a sample front-end application for UI as well. So you can use it for looking or interacting with the blockchain. And for this particular part, since our blockchain application cannot interact with any React app, so we need to build a plugin as well. So I created another plugin. You see here we have this NFT API plugin, which is been extended from the base plugin that we have. And this plugin is just creating an Express server, and then Express server has different endpoints that will give us the data. And to get this data, it's using the channel concept that we have, list communication architecture, and it's just getting the NFT token. And this get all NFT tokens are being defined inside the module that we simply have it here. So it's defined in here. So you have a plugin which is just serving an HTTP server because it's not a blockchain aspect or is not some online processing. So you have to do it. And now we start the front end. So we have a running application now, and it will take a few minutes to show this demo. So first thing is that you need different accounts that you can purchase some tokens, or you can like have those tokens. So you want to create an account. This is just generating a random passphrase and a random address for you. You just need to copy it and keep it somewhere. And I need another account as well, so I copy it and I keep it somewhere else as well. And then we make some transfer to the funds. So I say that transfer these address, let's say 1,000 euros with the fee of 1, and the passphrase, we can use the Genesis account, which has a lot of passphrases to fund these accounts, because these are the new accounts. Let's submit this transaction. So we have some problem in here. Always yes. So, and without going to the demo, I can go to the code as well, then and explain this to you. So in the front-end app that we have, this is the logic that you can use to create and send the transactions. And in the in the transactions, here is the logic that is responsible for creating those transactions. So the initial thing is that we need, first of all, we need the schema, and this is the schema that we had, like the attributes of the transaction. And within the transaction attribute, we have this module ID and asset ID. If you guys remember, we created these module ID, and inside the transaction module, I specifies the ID 1000. So I have to use the 1000 module ID here. And then I have this NFT ID 1, create NFT asset ID 1. So this is the asset ID 1, and this, once we create with the asset ID, we need to specify the nonce of the account. We need to specify the fee of the particular account and for particular transaction. And then we have the sender public key that we get from the passphrase. So you guys remember I got some passphrases on the interfaces. So from the passphrase, we use this get address from the passphrase, and everything afterwards we use this public key, and then we use the passphrase to sign the transaction. And once you sign the transaction, you have this transaction object, and then you can send this transaction object to the server, which is serving the API. And I can show you some utilities in the API, which is quite simple. Which simply sending the transaction to an endpoint, and this endpoint is being exposed from our HTTP API. And for the HTTP API, I can give you an example here that you simply need to import an HTTP API plugin from the SDK, and you need to register the plugin, and that's all that you need. And right now we have two different plugins. So those different plugins are serving two different stuff on the server, and then you can call those endpoints. And this is pretty much all you need to create and run an application. And this application will be available for you on our Lisk SDK examples repo, when you can explore it and you can go with the further details or post command or improve it from there. And I'm going to take a few more slides here. And so we developed a minimal blockchain application, which I showed you guys is running and without any configuration or something, with few lines of code. And then we develop a custom module. And within the custom module, we also develop a custom plugin to serve the data on a HTTP server. And this is all I have for today. And you can explore us further on our GitHub repo. There is a Discord channel. We have Lisk chat. You can go there and connect with the community. And we have dev.lisk.io portal, which you can go to ask any of a question. And if you want to explore more details, we also have the Lips portal, where we publish our improvement proposal, which is quite a lot and a lot of technical. So you want to explore it. And if you have any technical question, you can ask us on the dev portal as well. And that's all I have. And now I'm going to take any questions if there are.
Thank you, Nazar. And our first question is actually a comment, which is one that I was going to make myself, which is very much appreciated for you to do a live demo with all the things that can go wrong. As someone who has done quite a few live demos myself in the past, I am well familiar with the risks that you take. And sometimes the demo gods are not always kind, but I think you did a good recovery there anyway. So we've got a few questions here. Firstly, the Lisk node, you've got a very impressive array of achievement in quite a short space of time. Someone wants to know how many developers have you actually got working on the Lisk node project?
So currently, we development point of view. As of now, we have the team of 6 people who are actively working on the development side. But development is just one aspect of it, because to develop anything, as I said earlier, we are a research proven company. We base on everything on research. So we have a full-time scientist team. They are like PhD is in mathematics and other cryptographical related fields. And they provide us the full research. And then our team of 6 developers, which is right now, they can, based on that research papers and research theory, we go for development.
Okay, that's quite a team. And we have a question asking if we can write a smart contract in JavaScript itself.
Like this is a bit of a topic which can have a different opinion depending on the experience or depending on the scenario someone is asking. But I would say yes, you can develop a smart contract in JavaScript. There can be complication, there can be some problem that need to be solved, but theoretically it is possible to build it. It just need a VM, and I personally believe that JavaScript V8 engine provide you some kind of a context for it, so you can use it internally to build a VM around, and then you can run the smart contract inside that VM.
Of course, in any kind of consensus protocol, pure deterministic execution is important. So if you're talking about using a JavaScript engine, it's important to match not just the language, but probably the version and even the build number itself. Someone else is asking if the demo code is available, as in the code that you just demonstrated. Is there some way that they can download and play with it?
So it is currently not available, but it will be available on our repo, which I can like share my screen with you guys here for shortly. So we have a repo which is called Lisk SDK examples. You can go explore already. We have two examples, which is learning as a supply chain and a hello world, and we will put this demo that I just demonstrated into this repository by tomorrow. You guys can explore it further.
Okay, there you go. So that's Lisk SDK examples. If you search it it won't be too hard to find. Now, you mentioned earlier on some of the changes and improvements have been made, and one of them was changing block size to be measured in bytes rather than in number of transactions. It's actually a two-part question. Why did you make that change? And two, what actually is the block size limit and the frequency of blocks?
So the block size was changed towards the different, like from number of transactions towards the number of bytes, is depending on the different factors. And one of the factor is that we want to pre-estimate the growth in the data over the years. So if we have a fixed growth, we know that the maximum block can go with this size. So this will make us sure that the block will not, like overall the data will not grow, let's say, more than expected growth, which we want. But the other main aspect of moving to this technology was introducing the flexible dynamic fee system. So we introduced a dynamic fee system, and with this dynamic fee system, community can decide what fee they want to pay for a particular transaction, and the forgers can decide, okay, what fee they are going to accept for forging a transaction. And in that case, we don't know like pre-hand that they can fill up a lot of transaction or they can fill up less transaction. So why we have moved it to block by size. And so if there is a low transaction fee and then the traffic is coming hard, we don't we can scale up easily. If we have a, let's say, number of transaction earlier, which was 25, if we fix to the 25 and the dynamic fee is lower, people are sending a lot of transaction, but they have to wait a longer. But if it is like based on the size, then we can have a fixed size limit that can avoid to bottleneck the network, but it can still help people to grow within the number of transaction rate. And currently we have a 15 kilobyte block size within our SDK that is pre-configured. but it will be extendable. So if you are developing a use case which require a more block size, you can also configure it. That's not a problem.
Okay. And what's the block interval? How frequent are the blocks?
So currently, like with everything I mentioned is configurable. So currently block interval is 10 seconds, but you just need to go into the configuration and change it to any time, any seconds you want. I had tested personally for a 3-second interval, and it was working pretty well. So you can go to much deeper. But within the synchronization, we have some condition that we recommend people. On a personal experience, I will recommend to not go below 3 seconds.
Yep. Okay. So someone's asking if the SDK is open source.
Yeah, Lisk SDK is completely open source, and it's not like you can go and type in our Lisk SDK, and you will have all things here. And it's not just an open source. You can go into the projects. We have well documented managed GitHub repo, and you can see all the version, all the related stuff which are in the version, and you can explore all individual features. Let's say I was talking about block-based byte size. So if you click on this link, you will have a complete paper that how we are going to change and why we change from the block size to different one. So everything is pretty much configured and available for you to explore and learn.
Okay, great. We've just got time for one more quick question, which is probably a chance for a plug. Someone's asking if there's a Lisk community channel that they can join. I think you mentioned a Discord channel before.
Yeah, there is a channel Lisk Chat. So you can type in Lisk Chat, and then it will redirect you a Discord channel. You can sign up there, and then you will have a fully active community, which is like in thousands of people. So they are available every time to discuss anything. But if you have some technical question you want to ask, then you can post them on the Lisk Dev channel.
Okay, great. Well, we've reached time, so I'd like to thank you very much, Kazar, for the demonstration, and again, hats off to you for being brave enough to do the live demo.
Yeah, thank you so much.
We'll be back in just a moment with another focus on the business side of blockchain. So we'll see you in a minute.
Yeah, thank you.
Your app just crashed. It was struck by a hammer manufactured in 2005 by Harry's Hammers. The hammer's head is composed of 75% nickel, 20% steel, and 5% iron. Curiously, a hurricane just came down in Iran.
I'd like to introduce Marta Piekarska, who serves as the Director of Ecosystem at Hyperledger, which is a role I think I can well understand because I've taken a deep interest in various ecosystems around the Bitcoin space over the last few years. She has an array of experience, but formerly in security and privacy in the telecommunications space. But in 2015, she took the dive down the rabbit hole into the blockchain world through joining Blockstream and other Bitcoin-related companies. And as part of her role with Hyperledger, she's involved in evangelizing the technology at conferences around the world, and I suppose helping enterprise to actually understand what blockchain is all about and how it can benefit them. So for a more business-oriented presentation today, please welcome Marta, who's going to be talking about leveraging blockchain technology for business. Thank you.
Thank you, Steve. It's a pleasure being here. I must say, I wish we could do it in person. I think we all wish we could just meet finally. I'm fed up with my own little room. But while we are still online, at least it gives me an opportunity to speak to you at your homes, at your offices, without the need to travel, without the need to destroying the environment. As Steve mentioned, my name is Marta Piekarska. I've been with Hyperledger for 4 years, and my talk today, I'll cover some of the technical stuff as well, but really wanted to focus on case studies. So I'll tell you a bit more about Hyperledger, and then we will go into the use cases that have been implemented by members of Hyperledger, and I'll tell you a bit more of who are members of Hyperledger. And then if we have time, I wanted to cover a few things about how to get involved, because Hyperledger is an open source community and we welcome everyone. We truly believe that there is a space and opportunity for every single person to contribute to Hyperledger, no matter if you're just starting your adventure with coding, if you're a professional, or if you're a business person who has no idea about coding. And this is a mission of the Linux Foundation as well, which hosts Hyperledger. It actually all started with Linux, the operating system that was collectively developed and freely licensed. We wanted to provide Linus Torvalds, the creator of Linux, the operating system, a neutral home to promote the project and grow the market, host events, provide legal defense and infrastructure. Basically, you know, what happens if Linus Torvalds gets hit by a bus? There needed to be a space where developers that were freely contributing to the code base and the source would still have somewhere to go. It couldn't just disappear with Linus. But Linux Foundation is much more than just Linux, actually. Over the years, we've developed over 120 different projects. It really varies. Some people say 80, some people say 200, so roughly 120. It really depends on what you call a project. But the projects are always governed in a very similar way. So we take an industry that is interested in developing something with the use of open source. Next, we gather enterprises and the open source community, seeing if there's interest to try to create a project. We build a charter around it, build a membership structure and the governance model that is usually very similar from project to project. That's what Linux Foundation provides. And finally, start the project, start with some staff. So we find an executive director, we create the board of directors and so on. And from these initiatives over the last 20 years that Linux Foundation has existed, we developed some of the projects that are very well known to all you developers out there. I'm sure you heard about Node.js or Cloud Native Computing Foundation, Kubernetes, and so on. There are also projects that are very small and not very well known, like Automotive Grade Linux or EdgeX or LF Energy, one of the smaller projects we have. But all of them serve the same purpose: bring people together to collaborate on open source tools, framework, code bases to advance industry. And we believe, maybe foolishly, but we believe that in the Linux Foundation, that we, together with our broader community, are creating the world's largest technology investment to solve world's biggest problems by sharing the knowledge, the experience, and the expertise we have. We are dedicated to our goal and our plan. So 4 years ago, 3.5, 4 years ago, Hyperledger was introduced. Hyperledger was created as an open source collaborative effort to advance cross-industry blockchain technologies. It was hosted by the Linux Foundation, and it became a very global collaboration. It started with 30 companies. So many people know about IBM being one of the sponsors of Hyperledger. It actually it was 30 companies, including Blockstream, where I worked at the time. That's where I first learned about Hyperledger. It was also Intel. Digital Assets gave us our name. So Hyperledger as a name came from Digital Assets. And the two code bases, the two founding code bases came from IBM, who was doing their internal project on permissioned blockchain, and Intel, who was doing their project. This was Fabric and Sawtooth Lake, later renamed when it came to Hyperledger, Hyperledger Fabric and Hyperledger Sawtooth. Over the course of the years, we developed many more projects. Currently, we have actually 16 different projects. These span across libraries, tools, and distributed ledgers. And each kind of category has its specifics. That, you know, distributed ledgers are the base that you use in order to create the solutions built on top of it. So you take the framework, which is defined by the governance, the approach to smart contracts, the programming language it's used, and the consensus mechanism. That distinguishes one framework on one DLT from another. And then you build solutions using that technology that is provided by the open source community. Then we have libraries, which are shared across all common projects and are really focusing or looking at how can we save people from re-implementing the same thing over and over again. Tools help the community investigate and analyze their solutions. 3 of our releases are production ready, so they are in 1.0 or higher. As a matter of fact, Hyperledger Fabric is in 2.0. We have 15 active community working groups and special interest groups that are open to public. So anything that we do in Hyperledger when it comes to technology and involvement is open to anyone. We are not pay to play. You don't need to be a member to access those working groups or meetups or any kind of code bases. However, we do have membership. These are enterprises. We do not have individual members. These members span all across the world. We have over 50 members in China, member companies in China. About 30% is in Europe. About 50% are in Americas. And Hyperledger is really choose your own adventure. We say that it's a do-ocracy. So the more you do, the more impact you have. And this really means that when you come to Hyperledger community, you need to kind of decide, how do you want to contribute? How do you want to get involved? Do you want to code? Do you want to help with creating written content? Or do you want to just participate in meetings and contribute your thoughts and thought leadership? And then there are various ways that you can go down that route. You know, the code route is definitely much more technical and much more hands-on. Writing helps you get into the coding. I think for many people, it's kind of a gateway towards getting into the deeper technical contributions. But then business people, you know, they have loads of experience. They have loads of knowledge that they could share and build use cases and feed to the developers their needs for features, as well as observations around bugs. As I mentioned, Hyperledger's technical community is 100% open. It is never pay to play, and I can't underline it because we are very proud of it. And we are very invested in making sure that everything that happens in Hyperledger is welcoming, it's inclusive, it's that we promote diversity, and we listen to everyone. And the collaborative software development approach really ensures transparency and longevity required to bring blockchain forward to the commercial adoption. With that strong emphasis on open source, on having all the code and all the work done under Apache 2.0 license, we make sure that even if a bigger player steps down, doesn't want to contribute anymore, doesn't have the resources, it doesn't really mind. We don't really mind, because there is a vast big community that it will pick up the project if the project is important enough to them. And we are led by a very diverse group of technical contributors. As I mentioned, they are from all over the world. We are very much vendor neutral. And I know, some people confuse still Hyperledger with some of our funding members. But we really try to be really agnostic when it comes to vendors and technologies. We do not have favorite children in our house. Our greenhouse, as we call it, welcomes every kind of project. The philosophy that Brian Bellendorf, our executive director, had behind Hyperledger was to create a space where anybody can come with a seed of their idea and propose it to the community. If the community thinks that this seed of an idea is something that is interesting, if the developer manages to plant that seed of idea into everyone's head, and everyone in our greenhouse starts contributing, or part of our greenhouse starts contributing, fostering that plant, watering it, feeding it code, it will bloom into something beautiful, and everybody will be able to benefit from its fruits. However, we also realize that long-term, probably some projects will not survive, because not every plant survives. And if the community loses interest in a project, we have to accept it as well. So only when you hear that a project is in active state, can you be sure that the code will survive, that we believe that it's there in for a long run. All the code bases that are in incubation state, we will do everything we can to support it, and we will gather the community, but we can't ensure or give you guarantees around the code surviving whatever happens. As I mentioned, we kind of divide the greenhouse between distributed ledgers, libraries, tools, domain-specific projects, that's only one, as you can see, Hyperledger Grid, and Hyperledger Labs, which is our R&D center. That's where developers come when they come up with a cool idea and they really want to continue working on it, but they want to build a community around it. So the entry barrier is much lower, but also, the support that you get from Hyperledger is slightly less. So Hyperledger projects always have similar architecture, which is we provide the tools, which is the common software license, the certificate of origin as an IP framework, all the collaboration tools that we set up, we provide the promotion and branding, and we put in place security processes and practices for bugs. The code is being developed by a team of developer volunteers. These are people that work for our members and quite often are mandated by their employer to contribute to Hyperledger, but also people who do it on their spare time, no matter if they work for a member company or not. These developers are managing individual roadmaps and release schedules, so it's not up to Hyperledger staff to decide what is the next release feature. And they are also responsible for following Hyperledger policies and requirements and aligning modular code with other projects. We really want that interoperability or the cross collaboration to exist. And then Linux Foundation provides the infrastructure. So me, being one of the employees of the Linux Foundation, executive director, business operations, as well as big communications, marketing, and PR teams that help promote what everybody's doing. Our goals are to create enterprise-grade software, which really will be open source and will provide the code bases to support business transactions. It's always been the case for Hyperledger to the distributed ledger frameworks that we've been developing or were submitted to Hyperledger, they are focused on enterprises. That means that quite often they are permissioned, and they could be permissioned public or permissioned private networks, but they are always permissioned networks. The community-driven infrastructure means that anybody can really offer their ideas. And our mission is really to build those technical communities and educate the public. We want to build the commercial ecosystem. And actually one of our goals for each year is to make sure that the adoption of distributed ledgers, Hyperledger or not, is progressing. And then there is a growing trust in what distributed ledgers offer. Again, being it Hyperledger or not. So one of the ways that each one of you can start engaging, and probably the easiest way to engage with Hyperledger, is joining community special interest groups and working groups. Special interest groups focus on each vertical. And when I was asked to actually give this talk, the person who invited me said, you know, I'm really fed up with all of this kind of constantly talking about financial services and cryptocurrencies. I hope you'll be able to tell us a bit more about the non-traditional spaces. So here you go. This is the first time you can, or the first site in this presentation that you get into how wide approach and how wide applications of these technologies are. The way that special interest groups are formed is that if there are enough people that are interested in exploring how DLTs can improve or contribute to helping that industry, we just launch a special interest group, and then we, help find contributors, find people to meet. The groups meet online. They've always met online every 2 weeks. As I mentioned, they are open to public. And for instance, in healthcare, we have both doctors, we have pharma companies, as well as people that are just passionate about healthcare, but are deep into the technology. Same with telecom. This group is actually quite academic. We have quite a lot of students that that study networks and systems and want to explore distributed ledgers and telecom. One of the groups that actually is not here, but should be here, which is the Climate Action and Accounting, came out of MIT and Yale, and their project to track the resource usage and looking at how the CO2 emission and pollution, the way that we look at accounts, because effectively Earth and atmosphere is like our bank account. We can only put in as much CO2 before we overflood the Earth, and we can take out as much oxygen before we go into debt, which is actually happening right now. And with that, I managed to, sorry, here we go. I clicked the wrong link. Actually, once you get this presentation, all of these link to the groups, so you can just use the slides to go directly into the right group. The working groups focus more on technical stuff. So they focus on the specific aspect of a DLT across all projects and all blockchains. And again, you're welcome to join them. Just expect a bit more technical discussion. When it comes to enterprises adopting Hyperledger technologies and Hyperledger distributed ledgers, half of the blockchain, Forbes Blockchain 50, second year in a row, came or were built on Hyperledger. Not only Hyperledger Fabric, also Sawtooth, Besu, and Iroha, which we feel is a great achievement of our members, not really of us, our members. There are organizations all over, all sizes involved in this community. It's not only about your Accentures and IBMs of this world. It's also about those 3 people companies that are just starting and are being excited about getting into the blockchain space and the DLT space. So if you're interested in updates from Hyperledger community, we launched a specifically targeted towards developer newsletter. You can subscribe right now to it if you'd like. It's a very good way for tracking roadmaps and feature releases. Many people quite often ask me, it's such a big ecosystem and there are so many projects to cut through and to track. How do I know when Fabric is releasing something, or if Fabric decides to cancel its Fab token project? How do I go about it, or where do I learn about it? Well, you should subscribe to Dev Weekly, and we will then be able to communicate with you about it. And I promise you, there won't be a single piece of marketing in there. It's very strict. However, I was asked to talk about business cases. So let me talk about a few projects that we launched just recently, or case studies that we launched just recently that describe projects that are in production, that are real solutions out there. First is has been created and worked on by AAIS, which is an American agency for insurance. OpenIDL is the project that they built, which streamlines the statistical reporting process, which usually provides very little value to the insurance carriers, and also it actually provides insufficient information for insurance regulators. The OpenIDL project offers carriers a secure and reliable blockchain environment for the storage and selective sharing of statistical data, such as policy, premium claims, loss experience data and stuff. And as well as uses AAIS as an authorized statistical agent and advisory organization. So AAIS is one of the peers on this network, but it gives the warranty for analytics. And this means that with access to timely, very accurate information, regulators as well as reporting careers receive a more holistic and dynamic reporting and very good insights into and exposure into market trends. All of the reports are then being back published to the OpenIDL for immutability, for longevity. This project actually is currently becoming a sister project to the Linux Foundation. So we will be having an OpenIDL project that will be kind of hosted by the Linux Foundation, as everybody felt that there is a need for that neutral third party, being Linux Foundation, that will be very hands-off, but will provide the infrastructure the way that we do with other projects. It is using Hyperledger Fabric as the blockchain network. Another project is called Member Pass. It used to be called MyCUID, if you ever heard about it. This is done by actually 2 of our members, CU Ledger, which is credit union platform, and Evernym, which is one of the more or bigger distributed service providers out there. Evernym is the company that founded the Sovereign Foundation, and Sovereign Foundation is famously holding the world's most stable and biggest instance of Hyperledger in the deployment. So CU Ledger worked together with Evernym to build a secure anti-fraud identification solution. So the way it works is that credit unions issue a member pass to its members that are vouching, which is kind of vouching for the member's identification. the credit union member is able to hold and control the issue member pass, which can show to any third party. So you get into that verifiable credentials and verifier and provider and holder triad that happens in self-sovereign identity. And any third party can reliably really identify members using their member pass accreditation or certification that was issued by the credit union. This means that with MemberPass, credit unions can streamline how the initial member identity authentication process is happening across all call centers, and really drive up and lobby touch points and make more kind of engaging contributions and engaging systems. This is currently in production. It's very active. And I believe I talked to people from Evernym a couple of days ago, and they said that they were issuing something like 200-300 member passes almost a day at this point. Suramitsu, I promised not to talk about financial industry, but I couldn't help myself, because Suramitsu is a small startup in Japan that contributed code base called Hyperledger Iroha. Not many people on this side of the world know about Hyperledger Iroha, while in Asia, it's actually one of the more popular permissioned frameworks. Hyperledger Iroha specifically focuses really on the mobile applications and being very lightweight and very easy to plug and having a mobile SDK. So you can actually run Iroha nodes on Raspberry Pis. That's how easy and lightweight it is. And Bakong project was sponsored by the National Bank of Cambodia and is probably one of the first quasi-CBDC in production out there. It's not fully CBDC, but the aim was to reach the unbanked population, especially in rural areas, and to promote use of national currency instead of US dollars, which was something that Cambodian government and National Bank of Cambodia were worried about. The liquidity and compliance burden on payment service providers that are not banks is really reduced at this point, and the retail payments can deliver better services at lower costs. So you kind of Hyperledger Iroha is used to facilitate between banks participating in it, as well as merchants and as well as individual users. And finally, Joisto, which is a company out of Finland. They are doing something that they call Joisto Archiver, which is a very interesting document and data storage security service that meets all of the GDPR regulation. For those of you who don't know GDPR, it's General Data Protection Regulation that is basically making everyone's life horribly hard at this point, but makes sure that no data hopefully leaks. So they use distributed ledger to ensure that there is a proof that stored documents and their respective metadata have not been modified. And it's kind of interestingly combining the off-chain storage and cryptographic checksums of the documents and logs the events that happened in the archives to on-chain. So it's an off-chain, on-chain collaboration, which is the way to go with most highly secure, sensitive data. It actually supports as well removal of documents because all refund records in the blockchain regarding the document that has been removed do not contain any identifiable information. So you basically, by removing the original document, you break the relationship with whatever is running on the Hyperledger Fabric node. All of the projects that I've been talking about, you probably can see in the top left corner QR codes. You can snap those and go to the case studies that we published or talks that we published of those companies. So given that I have 10 minutes, I'm not going to spend much time on distributed ledgers and kind of what are the differences. I'm going to scan through it. You know probably Sawtooth. Sawtooth is the second most mature code base. It supports two algorithms, proof of elapsed time and PBFT. It is in production. It's quite popular, especially when it comes to flexible large case solutions. Hyperledger Indy is a project that supports self-sovereign identity. It utilizes zero-knowledge proofs to provide verifiable claims. It also supports selective disclosure. There are very good talks from our Hyperledger Global forum, which you can go to at the bottom. You have links there. Hyperledger Borrow is one that is probably worth mentioning because it's one of our smaller projects. It was the first one to create an Ethereum virtual machine for permission blockchains. It is now combined with Hyperledger Fabric and Hyperledger Sawtooth, meaning that both Fabric and Sawtooth can run Solidity smart contracts, which is a feature that many were very much looking forward to getting. They say that Hyperledger Borrow is the most boring blockchain, and that's because it's incredibly reliable and it's very well tested and very kind of comprehensive. It uses Tendermint as its default consensus mechanism. I mentioned Iroha, so don't have to spend more time on it. And then Hyperledger Besu. Hyperledger Besu is one of the earlier project or younger projects that we have. It recently came to us, but it came to us very well developed already. It was consensus that contributed that code. Some of you that are in the Ethereum space probably heard about a project Pantheon from the Pegasus team, and that's exactly what Besu is. It's a Ethereum client that can run both on Ethereum public network and private permissioned networks, and test networks as well. So it really provides this interesting interoperability between different networks, and it also includes several consensus protocols. So if you are in the Ethereum space, but you want to start flirting a bit with enterprise space, you can check out Besu. They have incredibly good documentation, very good training, and so on. I'm going to skip a few slides here. Maybe for, to just stroke a bit of my security ego. Hyperledger Ursa is our shared cryptographic library that enables people and projects to avoid duplicating others' cryptographic work. It's very high standard. It actually supports local cryptography, so like Russian cryptography or China-approved cryptography, so that we can ensure that Hyperledger frameworks can run in countries that normally would not accept American code. Then our newest project, which is one that everybody were quite looking forward to, is Hyperledger Cactus, which is a blockchain integration tool that is designed to allow users to securely integrate different blockchains. The way that you do it is that Cactus serves as the communication layer, and you write plugins for different blockchains to communicate with Cactus. And then Cactus takes care of working with other blockchains when you want to talk with them. So it's more a ledger interaction tool more than atomic swaps. And it's a project that came from Hyperledger Labs. So, it started as a small project between Accenture and Fujitsu. It turned out that they both actually were working on the same problem and were thinking in a fairly similar way. And they started working together and quite swiftly moved from being an idea to being a project within our greenhouse. And the reason why it's called Cactus is because actually the majority of the work was done in Arizona during our Hyperledger Global Forum, which happened in early March this year. So it's really like very fresh code, but because it was in Arizona, and those of you who have been to Arizona will know that it's full of cactus, the code is now called Hyperledger Cactus. If you haven't been involved in an open source project, I know that it could be quite intimidating. So the three things that you can do is feel free to lurk, don't wait for invitation, and just read the code of conduct to know what you're operating under. This is your invitation. This is your time to go to the website and read a blog post and see if you find it interesting. Show up to a special interest group meeting and say that they're all wrong, or maybe start working on a project with someone. Good general guides for getting started with open source are here. There are those 4 very good kind of guides that we put together, or some of our colleagues from Mozilla and other open source projects have worked. So the basics about the tools: first and foremost, you always will need a Linux Foundation ID, which is a free account. It just helps to really look through or access all of the collaboration tools that we have, which is Jira, which is Chat, which is the wiki, which is the mailing lists. It allows you to combine everything into one. It's a very simple process as well. Then we have those 6 collaboration tools, which is the Linux Foundation account that I mentioned, Chat, which is a Rocket Chat instance where there is a more online, more real-time discussion, mailing lists. Each project has a mailing list, as well as all the special interest groups and working groups and so on. So loads of mailing lists to join. Some of them are very active, some of them are very not active. All of the code is stored on GitHub. All of the bug reporting is done through Jira, and we have our wiki, which is where all the development is being documented. So this is where you'll find project updates, also what special interest groups and working groups are doing. This is where you'll find also information about technical steering committee, governance, and so on and so forth. If you want to contribute to Hyperledger, first of all, read the contributing guides. It's quite useful. Get a copy of the repository from GitHub. Find the issues that you want to work on, or think of the issues that you want to offer to, or features that you want to offer to the community. Make your changes, create pull requests, and expect comments and address those comments. If you have an idea for a new feature, if you're, for instance, a PhD student that is working on some kind of a project or a paper, and within that paper you want to build a new feature for Iroha or Besu, first I suggest contact the maintainers on the developer list and ask what they think about it. And don't be offended if they think that there are better ways to do it or different ways to do it. This is not against you. This is so that there is a consistency in the thinking and philosophy behind each project. Depending on the project, source code can be found on either Gerrit or GitHub. The Gerrit repository have a read-only mirror on GitHub, just as a side note. The issues are being tracked on either GitHub or Jira, but all security bugs should be reported in Jira. We actually have a bug bounty program. So if you want to earn money, you can try breaking Hyperledger Fabric and get paid for actually breaking it. You don't need to try breaking our website. There is no bug bounty for attacking our website or GitHub for that matter. If you want to learn more because you're just starting the journey, I do suggest you take a look at our certification. We have free courses, which are 4 free open source courses that you can take at any point in time. These are high-level courses, as well as looking more into the in-depth technical aspects of things, and 2 courses on identity. Then we have a developer certification. So if you're at the stage where you are feeling very comfortable with being a Fabric developer or Fabric or Sawtooth administrator, you can take one of those courses. And if you own your own company that is providing training or services, then you can always ask to be certified as a training partner or service provider. I mentioned that. And with that, I can tell you that all are welcome here. And we really want to make sure that we create an inclusive community. So if you feel that the community is in any way offensive, please do let me and my colleagues know. Thank you for listening. I'll take some questions now. And I welcome you to our Hyperledger member community, because now you're part of it.
Thank you very much, Marta. That was really informative. There were a few preconceptions I think I had about Hyperledger, which you've disabused me of in the last little while. And there's certainly an awful lot going on. I've got some questions here, but we usually end up with a comment, so I'll start with that, which is from Stefan. And it's quite simply, thank you for sharing this. Clap, 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 4 claps. So
thank you.
Thank you. I'll have to ask you to forgive my ignorance if what I'm about to say is not the case, but I often hear Hyperledger referred to as a private and permissioned blockchain, and in fact, it looks like it's a set of tools for anybody to create one. So the first part of that question is would you agree with that categorization? And the second part is that I suspect the issue of public versus private blockchain is going to become a very hot topic of debate over the next few years. I'd like to hear your thoughts on the advantages of private.
Sure. So I think that there is a spectrum. There is the private permission, and then permissionless public, and then there is the middle ground of permissioned public and permissionless private networks. And depending on what you're doing, you're really looking at a different set of needs. So to come back to your kind of going backwards, what are the advantages? Well, it depends on your use case, right? If you want everybody to use or be able to participate in your DLT solution, because you, for instance, create a cryptocurrency and you want as many people as you can as you can convince to use that cryptocurrency, then you do need a permissionless public network. However, when it comes to things like, say, a system that is requires high auditability and high transparency, but within a very small group of people or very small group of participants, for instance, among hospitals and doctors when it comes to healthcare, then you don't really want a permissionless public network, because obviously, you don't want me to write into your healthcare records information about you having some kind of a STI disease or something, right? You kind of want it to be in control. Only your doctors, not even you, but only your doctors to be able to write into that record. So that's why you need permissioned private networks. There are a lot of situations, and I hear what people say that it's not a real blockchain. Well, blockchain is just a technology, right? It's a way of storing information in a chain of blocks, and then you use the consensus mechanism, you use the smart contracts, and you build the system, which is a DLT system. Now, the governance that you provide really depends on your use case. Same, even permissionless public systems do need a minimal viable governance, a decision, what will we do when things go wrong?
Yeah.
And sorry, forgot to answer the first part, which was about Hyperledger having not only permission private networks. Yes, Hyperledger Sawtooth supports permissionless private networks. And Indy should be considered a private permissionless network, because you can create a system, a credentialing system, when only certain issuers and credential providers can be write to that network, but anybody can see, verify the credentials.
Okay. I agree with what you're saying, that it's use case dependent, and in some cases you almost certainly might want to maintain either the permissioned or the private elements of it. I have a feeling that there are probably some elements of the corporate community, though, that defaults to the private side or even the permission side because of a lack of comfort. And I think I've seen a pattern over the last 20 or 30 odd years even. And I'll give two examples. One is the internet and one is cloud. In the early days of the internet, we saw a proliferation of private intranets, companies that simply just weren't comfortable with going out there into the world. But then, 10 years kind of passed, and we found that there were obviously cases where they needed to keep things internal, but a lot of things that they didn't necessarily need to. Or that there were advantages to putting them out on the public internet. They started to do that as they gained confidence, and large corporations, especially banks and things like that, they're kind of slow moving. Do you see a similar thing happening with blockchain, with a gradual migration of some of these use cases from private to public?
Not really, quite the opposite, I would say. I totally agree with you. A lot of So I think that what you're talking about is a good example of just companies trying to use DLTs where they really don't need the blockchain, or building a DLT where they really don't need the blockchain. Because when I hear, oh, I really want a blockchain, but I kind of want to remove things from it. And I want it to be just me and maybe my, one of my colleagues that is using it. And we kind of didn't really need a consensus mechanism because they're like, well, then you don't need a distributed ledger. Sorry, like that's not your use case. So I do think that in many cases, we are still seeing way too many companies using DLT just because. Although this year, I would say it's a year where I'm seeing much less of it. And it's really like the rubber hits the road. And now we are seeing, okay, well, these didn't make sense and these really make sense. When it comes to different applications. When it comes to, I know, and maybe this is just, a cognition bias because I'm in the permission space, but I do have a lot of enterprise members, companies that come to Hyperledger saying, we experimented with the permissionless public space, but we kind of like using Besu. It's mostly moving towards Besu out of all the projects.
Yeah, I work on a public and permissionless blockchain, which I kind of argue there's no such thing as permissionless, but that's another debate. I won't try to have that one here. But one thing that I do find is a lot of businesses start building things or want to build things on a public blockchain, but they actually really do want the permission side of it. So there's appetites for all of that, I think, out there.
I've seen a lot of very successful usages of both. So having, using the permissionless public network for kind of high security assurance and real kind of bulletproofness, if you want, and then using mostly Fabric at this point for having kind of the consortium style of negotiation transaction, creating channels, creating the CouchDBs and so on. Yeah.
I'd like to turn to the open source element of it because this is a particular interest to me. Firstly, I'd like to ask, most open source projects, they kind of need to reach some kind of a critical mass to survive. And there's usually some sort of a bootstrapping process that gets them there. Bitcoin was kind of unique, I suppose, because it had a ready-made community of people who were just waiting for something like that to come along, and that's what created enough developers to give it momentum. How did that happen with Hyperledger?
I think it was basically an answer of what the heck do we do with Bitcoin from the enterprise world. So I remember when I was back in Blockstream and Hyperledger was just being started, it was initially thought of as a standardization body. And I was actually really against it. And I was actively fighting against creating Hyperledger. As it turns out, not really very rational thing to do. But in general, back in the time, it's 4 years ago, when people were talking about building standards, it's like we still haven't successfully had one production deployment. Why are we doing standards now? but it was really just these 30 odd companies that were like, there is this Bitcoin space, and it's clearly something that is interesting, and it's clearly something that we kind of want to join, but how do we join? Like, what do we do? And then there was Linux Foundation, which really had experience with doing that for other verticals, other industries, and that's how kind of where this critical mass came from. And once it being launched, having big names like Hitachi, Fujitsu, IBM, Intel behind it, and members of Linux Foundation, so companies that really were already part of the crowd, it was just different projects, that kind of built really the momentum.
Yeah. I noticed on one of your slides, I think there were 4 columns, and there were different guides for how to get involved in blockchain related or ledger related open source communities. And one thing stuck out to me because I got involved in Bitcoin in 2011, and it was a pretty brutal meritocracy. That was probably how I described the culture.
Yeah.
You needed a little bit of emotional resilience to do
yeah.
it. And one thing that struck me was that I was involved with Bitcoin for many, many years before I actually ever came across a woman in the space. And it's definitely changed and improved, but it is still the case that it's an extremely male-dominated industry. Do you think that culture contributes to some element there? Because the capability of the women that I've come across in this space is absolutely on a par with everybody else. But I'm interested in finding why the take-up is so slow.
So I think that initially, absolutely, you're right. The culture was, gosh, I remember the first consensus where they had actually ladies, a party where there were ladies painted in gold serving drinks. I was like, God, I'm a very liberal person, but having women being treated just like hostesses and completely not caring about them, I was outraged. And that continued for a bit. But I think this right now, it's actually really changing because this technology is really democratizing, and it's democratizing across, small players versus big players. It's much easier to become successful startup in the DLT space when fighting the big players. It really is democratizing in terms of parts of the world. I think that this is one of those these situations where you have as many really interesting projects happening in China, in Africa, in India, in America, in Europe. It's all over the place. And I do see many more women. I think that actually I've read some studies that show that at this point there are more, obviously the percentage is still small, but it's higher than in blockchain space than it's in computer science in general. So it's really, really changing. And I think it's a very positive thing. And to be honest, with everybody that I've spoken to that come from the outside and assume, this is like very weird environment and everybody's like super into anarchy and all that stuff. Everybody's response at the end of the day is, wow, I didn't realize everybody's so friendly here. Like, how does that happen? So I do think that it takes specific people, like, you have to have certain quirks to be very engaged in this industry, but it is getting better. It's getting there.
It is, yeah. I think Bitcoin and blockchain in general seem to be growing up, and one of the things I think about the space is it really is hardcore back-end work, and it breaks the stereotype that the women that get involved in engineering all tend to be front-end, which is a comment I hear quite a lot. I'm very proud to say one of our best engineers in N-Chain is pure back-end, and she can kick the asses of almost any of the boys. So, I've got one last question, which is about the nature of dealing with open source communities. I work in a very corporate environment now, and of course, that's kind of a little bit different in that technical strategy tends to come from the top down, and we obviously encourage creativity at all layers of the organization. But In an open source community, you don't have any kind of a hierarchical structure like that. So what are the kind of unique challenges of managing these distributed and volunteer groups of engineers to get stuff done?
Lack of incentives. Like everybody's there spending their own free time. You know, the situation where they are actually mandated to contribute, like Bosch is very heavily currently contributing to Hyperledger, and they have a army of developers that are being paid to contribute back to Hyperledger, but that's very rare. Dealing with the fact that people are doing it out of their own goodwill, encouraging them to work together and to want to contribute back. It's really easy to convince people to use open source. Everybody wants free code. It's much harder to explain to people that if it's only being taken and nobody's giving back, there won't be anything to take at some point. So I think the sensitivity to the differences in cultures and kind of approaches, and also understanding what different perceptions of what open source means and is, combined with the lack of financial incentive to contribute back, is one of the things that I still am learning how to do, right? How to deal with.
Certainly, yeah. I mean, I've worked in a lot of open source communities myself in the past, and it's an interesting and unique challenge. But the results are, well, they can range along a big spectrum, but they can be spectacular.
Yeah.
Okay, so we've approached time now, and I'm actually going to be signing off as host, and Francesca Pollard will be taking over for the next session. So. I'd like to thank Marta for a very informative presentation, and please stick around for the next bit.
Thank you so much for having me.